And we are recording. There we go. All right, so I think, let me get my presentation on here so you guys can see the screen. And Jaden?
Yeah.
Yeah, I'm not sure why I'm not seeing the share screen. Oh, wait, hold on. Got it. Never mind, I needed to just say it out loud. All right. And everybody can see the screen that I'm sharing, yeah? Okay, perfecto. Okay, great. All right, so Jaden left off with icing yesterday, so we're just going to continue with that and then go from there. So with the icing, pretty much he went over mostly everything. This is just the last bit of it. And pretty much icing can cause extreme hazard to the aircraft, pretty much. I mean, it's ice. It can cause a lot of damage. So we have three main kind of icing, types of icing. And those are probably the three things that we're going to try and remember here. We have rime ice, clear ice, and mixed ice. Those are the three big things that we'll always hear in aviation when it comes to icing, what kind of icing it is, and how it'll affect us. When we hear these three different kind of icing, we'll know that we gotta stay away from them. Rime ice, it's a mix, oh, sorry, not mix, it's a milky, it looks milky, like a coat of ice, but it looks more milky. It's not clear. It looks like milk, pretty much stuck to the aircraft. It normally goes to the front of it because when the aircraft is flying, it's basically just building up ice on top of the ice that's already there, and it just causes like a milky way, like substance looking on top of the ice, on top of each other. So that's basically rime ice. It's just the buildup of the ice in the front of the aircraft. Clear ice, that's basically what it is. It's clear ice. You can barely see it. You'll see the shine to it, but most of the time it's just shiny, but it's clear. And mixed ice, that's exactly what it is. It's a mixture of the rime ice and the clear ice put together, and you can see it a little bit more because of that rime ice with that buildup, and then some of that clear ice that's smoothing out. So those are the three major types of icing. And also one of the other things that we need to make sure that we remember is that the icing conditions generally found when surface temperatures are below 10 degrees Celsius and visible moisture. So when we have visible moisture and we're below 10 degrees Celsius, that's when we have icing conditions. So whether it be rime ice, clear ice, mixed ice, depending on the temperature of that time, but that's basically important. We have rime ice, clear ice, and mixed ice, and we have icing conditions when our temperatures are below 10 degrees Celsius and we have visible moist in the area. So these are basically how the ice looks like. These are examples. You could see here, you can barely see it. It just has a shine to it, but all that water developed, and because the aircraft is moving, it just kind of smoothed out and it looks pretty clear. And here you see it build up here, not really here, because this is where we'll have heating. So it'll get rid of it here, but there's not really much heating here, so you can't really get rid of it there, which is why they'll do de-icing on the airports and stuff like that before they take off. There's also the Rheimheiss. This is how it looks, and then the mixture of the both. All right.
Can I just add something with that?
Yeah, sure.
Going back to that picture of the clear ice, the reason why it's clear and it's smooth and stuff like that is because what happens is when you get those super cooled liquid water droplets and they hit the surface of the aircraft, instead of freezing instantaneously, it freezes as the wind, right, as you're flying, pushes the water droplets across the surface of the aircraft. So it makes it nice and smooth and it freezes and clear. And that's what creates that clear ice. The Rime ice forms differently. Those super cool liquid water droplets freeze almost instantaneous when it hits the surface of the aircraft. So that's what gives it that milky white, kind of rough, kind of bubbly look, is because those water droplets are freezing instantly and making kind of ripples on the aircraft. And that's how you are able to tell those apart.
Thanks, Jaden. All right. Stability. So we're gonna move away from our icing now, and I think that's the end of looking through the icing. We're gonna move away from that, and we're gonna go to stability, which is basically air, the stability of the air, instability of the air, all that fun stuff. And with that, this is basically saying the diabatics process, which is basically how our air becomes stable or unstable based on how the air either compresses or expands. Does anybody have aviation background? 1, 2, 3, 4, 5, 6, 7. Oh, okay, a lot of us. Yay, great. Okay, so perfect. All right, so with that, we know that air is all over the place sometimes, but the basic root of how we start this whole air thing is that they have this diabatic process where it's basically describing how air is and how it starts for us to build up on why it's unstable and why it gets stable. So basically it's saying you have air particles that it's in a bubble, right? And it's moving all over the place. But when it's in a low pressure area, it moves fast, but it also has a lot of space to move all over the place. But when you compress it, like let's say you put air in a tire, it's compressing, right? You're putting that air in a compressed area. Because it's putting in a compressed area, the air heats up because you're compressing so much air in one small area. Now, with the opposite effect happens if it's in a bubble and it's a bigger bubble and it has a lower pressure area, that air has more space, so it becomes cooler. That's basically what it's saying in a nutshell, this diabatic process. Does anybody need me to explain that a little bit more? Because okay, so it looks like we're pretty good on that. And basically, in theory, what this also saying is when that air pocket, because of course the sun hits the earth, and if air pockets comes up, right? When that air pocket comes up, the more it goes up, the more the air pocket will either get cooler or get warmer based on the temperature outside. It'll either help or not help with our environment. Let's see here. So basically, this is what he's saying. So with our stable air, the temperature outside is cool, and then the temperature inside that air pocket, it's even cooler, and the more it rises, it gets even cooler. However, it keeps it stable because the air doesn't go up and out. It just keeps, it'll be stable, so it'll fall back down because the air is stable. The air inside that pocket is cooler than the air outside. And our unstable is the opposite. The outside air is cooler and the inside air of that pocket is warmer, and because of that, it'll rise and it'll eventually, well, with this here, sorry. So this is the neutral, which both air and inside is stable. So everything is the same. And then the unstable. And then when it gets to the, Jada, if you don't mind helping me explain this one, because sometimes I have a hard time explaining this whole stable air part.
Sorry, 1 second. I'll get my kid in the car.
Okay. Well, does anybody need me to like break it down a little bit more, or doesn't understand it so far? Please let me know if you guys don't understand it so far so that we can figure it out. Okay, so the air pockets go up and they can either be neutral, which in this case it's neutral, all temperatures are the same, and unstable, which it'll become cooler, but then as it gets to a condensation level, which is the level of where the temperature in the air changes, the air pocket will also be, if it changes to cooler and outside is warmer, or if inside is cooler and outside is warmer, it'll be unstable because that air pocket now is going to do something different. It's going to cause clouds. The moisture is going to be in that cloud. And we're going to get more clouds because that air pocket temperatures change from the temperature outside, from the lower level up to the higher level. When that condensation level changes, which is that temperature changes, that air pocket would also change, and that's how we'll start getting our clouds and stuff like that. And it's pretty much what this is saying also, that unstable, it'll become different levels and it'll change based on the temperature outside versus the temperature inside that air pocket. And this is just calculating the whole thing, and we don't need to get into that. All right, so since we know,
quick and like you're saying, sorry, now that I'm in a place. So basically the difference between like stable air and unstable air is stable air resists that vertical movement. And usually you have lots of layers of clouds, and weather's, better, and precipitation is pretty steady. Unstable air has a lot of vertical movement, right? We talked a little bit about yesterday that. Sorry, my kid is yelling. Talked a little bit yesterday about thunderstorms, and that air, that vertical movement is important. It's a lifting mechanism to help build thunderstorms. It's also important for that cloud development, like Jody was saying. And so that's why unstable air mass is a big picture on getting through that weather. So if we have stable air, you're going to have great weather, and unstable air, obviously, you're going to have more turbulence, more precipitation, going to be windier, that type of stuff. So, yeah, just like you're saying, Jody.
Thank you. Anybody have any questions so far? Should we go over anything so far? No? All right, sounds good. All right, so with that knowing of how that wind work and how, not winds, sorry, how the air works. We can figure out, we can put winds in it, because with that air, with that movement of air, depending on how that movement of the air works, winds will come in and will create turbulence. So I'm pretty sure everybody has been through some kind of turbulence on an aircraft. Does anybody
Does
have
anyone?
any?
Oh, go.
Does anybody have any crazy turbulence stories? No. Oh my goodness. I
I've
always,
thrown up a couple times from turbulence flying.
me too. Uh, there was
Hopefully,
one,
there's a few more people other than us that have done that too. But
right?
I get
I'm,
motion sickness pretty easy though.
yeah, me too. Very easily. We were waiting to go into Newark, and there was just so much turbulence on top of the fact that we had to hold before we landed. So we were in that turbulence for a solid 30 minutes. I literally held it in, and then when I touched down, I could not hold it anymore. It was bad. It was bad, but
Yeah,
that,
that's same for me. We're going into Salt Lake, which is notorious
oh,
for being turbulent,
mm,
and same thing before we touched down. Just all that had some strong winds blowing across the mountains, and it was bad. But
yeah, yeah, because Salt Lake City, they do have, they change winds a lot, right?
yeah,
Yeah,
the wind patterns there usually they change.
change,
Uh,
drastically. Brian, go ahead. Sorry.
It's not, not like what the videos you see on YouTube with like, drink cart. Through some weather once we were um, coming in, we were coming into Bush Intercontinental in Houston, and we were banking to, like, I guess, make a turn to do the final approach, and then all of a sudden there was like a gust of wind or something that made us bank like even way more. I mean, and it was kind of that feeling of, is this sucker going to flip over kind of thing. And it lasted for just a couple of seconds, and the pilot came on and he was like, don't worry, everything's fine. And he explained what it was. But yeah, that was probably the one where I got a little bit nervous.
Oh, see, that's a good one too. That's sounds like a wind shear where he's landing and that wind just kind of shifts. And so that captain had to hold on for dear life to make sure that he lands that bad boy nicely. Well, that's good. All right. No
does
one
anyone
else?
enjoy turbulence? I semi enjoy turbulence, even though it does make me motion sickness sometimes. I don't know.
Uh,
I think it's kind of fun, but that's because I just know how safe things are. But
I just don't like it because I would like to read on an aircraft, and when the turbulence starts, I can't read. So, but that's good. Some people like it. I like it when I'm doing the long trips. So when I go to Korea and I'm sleeping, it's like rocking me to sleep. All right. All right. Let's move on to beautiful turbulence. All right. So basically, everybody here knows that turbulence is bad. We have different types of turbulence. We have light turbulence, moderate turbulence, severe, and extreme. Pretty much light turbulence is that little jump that you feel when you're on the aircraft, like just a little pockets of jumping on the aircraft. Nothing too crazy. Sometimes you barely feel it. That moderate is when you definitely feel it, but it's not something that'll make you jump out your seat or anything like that. It's just bumpy, and it's there. And hopefully we get through it. Severe, we don't really want to go through severe. We all feel it, and we all feel it really good. We don't normally go through severe. That's really bad if you go through severe. Also with moderate, we don't really want to go through moderate, but sometimes you don't really see it. It just happens. We try to avoid it if we can see it, but severe, we definitely don't go through any of that. Extreme, it's
Can I
definitely
just mention something about
Yep.
severe?
Yep.
So the definition of severe turbulence is a momentary loss of control of the aircraft due to turbulence. So even if you go through severe turbulence, chances are, right, pilot is very rarely going to ever admit that they lost control of the aircraft momentarily. That's how bad it is, right? So if you go through turbulence and it like shuts off the autopilot or something like that, like causes autopilot to disengage, that end is pretty bad. I've had turbulence on some of my flights that have the AC pack stopped working mid-flight, going over the mountain wave turbulence, going over the Rockies, just west of Denver. So it is really bad. Like everything up to that point is considered moderate up until if you lose control of the aircraft, that is now severe. So anyway, there's a lot of paperwork involved with that. So that's also the other reason why pilots won't ever admit that if they hit severe turbulence, they don't want to do the paperwork. They don't want to admit that they lost momentary control of the aircraft, right? That's kind of their job. It happens, it's not their fault if it does happen, whatever. But so it's more of kind of a pride thing. But so again, it's very rare that you actually see that. But that's kind of like the videos that you see online where like, the whole drink cart goes to the ceiling and everyone's showered with drinks, snacks and stuff. Like that's severe turbulence. So anyway, just thought I'd throw that out there.
Thanks, Janet and Christopher.
Yeah, so one thing to remember is when an MD-11 reports moderate turbulence and you're in a King Air, for the King Air, it's severe. I learned that one the hard way.
Mhm.
And also went through unforecasted icing conditions. Had to do an emergency descent. Well, the turbulence descended us about 300 feet instantaneously, and then the icing started. And so we did an emergency descent below the clouds. And yeah, it is a lot of paper. Yeah, so just one thing to keep in mind is, huge airplane saying, hey, I've got a little light chop, and you're in a twin engine King Air, you're going to have moderate turbulence probably.
Yeah, that's a key point also. Thanks, Christopher. Yeah, if depends on the aircraft that's reporting it, it could be different from your aircraft. If it's a small aircraft reporting a light turb and you're a bigger aircraft, it's most likely you won't have to worry about it. But if it's a big aircraft reporting a severe, everybody needs to notice it, because if that big boy can't go through it, then everybody needs to pay attention to it. And sorry, I don't know how to say your first name. Lake.
Nichelle.
Nichelle.
Nichelle, like
Nichelle.
Michelle, but with an N.
Okay. Okay.
My question was, which one of these would cause like the oxygen mask to drop? Would it be severe?
Yeah, severe could definitely cause it, but the extreme will definitely do that.
For the most
Okay.
part, the oxygen mask shouldn't drop unless you lose pressurization. So the only reason you would have oxygen mask drop from turbulence is if, like, again, it knocks the packs offline and you lose both packs where you hit, turbulence so bad. Sometimes, it may knock a panel loose because all there are is just panels that are latched. So it may sometimes do that if you hit strong enough turbulence, but for the most part, they shouldn't be popping down if you're hitting turbulence. That's typically, again, when you lose pressurization in the aircraft, or a rapid depress. That's what we call it.
And Betty, you're saying you've been in a severe turbulence. Do you want to elaborate on that?
Okay. Hi, Jody and the classmate and everybody who's on this video. I am a flight attendant for Korean Air. And when we flew from Alaska, Anchorage towards Paris, that is the time of the weather change dramatically, and it did drop. Pilots did inform us, but even though the pilots, as Jaden mentioned, it is very hard to control. It dropped very seriously, and all the passenger very, very scared, include myself. We secure everything in advance, but still we bounce up. We bounce, all of us. We had on seat belt, but I can feel that we still bouncing up. And about 15 minutes, we over that kind of weather.
Oh wow. Yeah, that could be that sounds horrible.
It is
And-
very difficult. Yes.
Yeah, over that Alaskan area, we do have a lot of mountain areas. So starting from there, you're right. It does get choppy, and the weather does seem to change in that area.
Yes.
Funny. Well, not funny. The flights that I dispatch at Delta is China and Incheon and Japan flights. So yeah, I know very well what you're talking about,
Yes.
Betty, in that area.
Yes, it is.
Yeah.
I'm from Taiwan. I'm not from China, so a little bit
Oh no,
different. Yeah.
no, yeah, but I mean like the flight routes
Right,
going
right.
Korea, Pudong, and Japan. Those are all like those
Oh,
routes
yes.
are
Yes.
yeah.
Yes, I based in Incheon. I live in Korea for many years too.
Oh, okay, cool.
Yeah.
All right, let's see here. So this is basically explaining that whole reason of why we get turbulence with that adiabatic processing of that air rising and cooling, and based depending on that instability of temperature and stuff like that, it can cause turbulence. That's basically what this is describing, how depending on the temperature of the air, of those air pockets, or and outside temperature, it can cause, that's what will cause those difference in turbulence, how severe and how different it can be. And also there's also mechanical turbulence, and that wind shear that we were talking about, Brian, with that change of wind when we were descending. So that convective turbulence, that's basically sun cooling the surface, and with that sun cooling the surface, that surface is heat is rising from the surface, and it can either cause clear air, which is the thermal turbulence, which you don't see it because it's the air is clear, and based on the temperature of the air outside versus the air pockets, it's all pretty stable air, but the captain could feel it because that air is moving and rising up. So that's that thermal turbulence. And with that convective, it's the same thing. However, that temperature outside is changing so that we get clouds, and so we could see the clouds developing. We can fly over those clouds, but flying under those clouds would not be plausible because that air is rising in that throughout that air, and that's when that changes of that air is moving. So that air pocket is going up and down, because like with that adiabatic process, the heat pockets will rise, and depending on outside, the it'll fluctuate, and it'll give us turbulence underneath those clouds. And turbulence, again, with turbulence, and well, actually, same thing here. It's all those, depending on the winds and stuff, it'll cause extreme turbulence, and it'll also cause thunderstorms based on how much moisture is in that air with the air pockets and developing, going up with the temperature outside and those air pockets, it'll cause extreme thunderstorms and things like that. The mechanical turbulence, that's basically things around. It's basically describing exactly what this picture is showing. You're at the airport, you're taxiing to or from the gate, all those buildings, based on the winds blowing, it'll give us turbulence taxiing just by taxiing out of the airport or taxiing into the gate, whichever one. So that's a type of mechanical turbulence. Also, another one would be the mountain waves. So the aircraft the wind goes through the mountain, depending on how the air is. You can get major mountain waves because that wind is going over that mountain, and because that wind is going over the mountain, it's basically needs space to go somewhere. So it can either make a big wave and then you can't fly over that area, or it can make a small one, but either way it's creating a wave. So that's also mechanical kind of turbulence because it's an object that's in front of that wind and it's causing it to give us a different effect, which is actually what we're seeing here. This picture is basically the wind moving over the mountain, and it'll create a big drop, and it'll either move fast, go down, and go back up, or in this case, it'll cause like doing a rope, and it just waves, and it'll just keep going, and it'll go vertically and go all the way up, and it can go really high where we can't even fly over that mountain wave. Right here, we're seeing that vertical wave of mountain where that wind goes over, and it will go either really high or really low, and it could go anywhere between 20,000, 39,000 feet, depending on how that wind dips over that mountain. And this is basically another chart of it. You can do in these slides, it'll give you the different names of it and stuff like that, but I don't want you guys, I'm specifically not going over them because dispatching world, a mountain wave is a mountain wave. We either can't go over it, or we can go like a little bit over it, or depending on the flight level of that mountain wave, right? We just need to know the concept of it, which is basically that wind going, but then it sees an object and it goes over that object and it becomes a ripple effect of wave, and it could go all the way up vertically to a high flight level or a low flight level, depending on how that object is in that area. And it can also cause clouds depending on the moisture in the air and how that wind is moving. And this is also another one where they call it the hydraulic jump, which is that wind just dips real fast and goes all the way up, and then it just becomes also becomes like a wave, and it'll be farther along that air. And this is what I'm saying, it could go really high up or fairly low, but might be a flight level where we can possibly fly over, depending on how high that wave goes up to. And this is another solid image of how that looks. And you can see here, these are the clouds that creates over that wave where that wind is going, and then that cloud forms because of that mountain wave. And that's how meteorologists will see how that wave is developing and if we need to avoid it, yes or no. And actually it's 8:10. Do you guys want to take a few minutes, or do you guys want to just keep going? You guys want to do a 5 minutes or no? Keep going, yes or no?
Say go to 5:30 or 6:30 your time. 20 more minutes.
All right, we can go through 20 more minutes. All right, That's fine. Sounds good. All right, perfect. All right.
So going back a couple slides real quick.
Yeah, sure.
Just right there.
Uh, this one?
Yeah.
Yep.
Okay, all good. Thanks.
Uh-huh. All right. And this is basically doing this, showing us the same way of how it goes. Now, Jada went over the troposphere, and with that troposphere, also you have the tropopause, and in between that, you have that jet stream. So all those things play into a factor with that mountain wave and how it will affect us, how high it'll go, and things like that. And this is our wind shear based on where the winds are and that shifting of direction. That's how our wind shear happens. So basically, that's the same thing that Brian was saying when he was landing. He got a real shift in that aircraft. That's because that wind shift dramatically. Let's say it's going from here, and that wind on the other flight level is going this way. So it becomes wind shear because that it's a different direction in that wind. So one flight level, it's going one way, and the other flight level, it's going another way. So they're both not synced. So you end up getting, when that flight is landing, you end up getting a shift in wind. So that captain has to control that flight level and try to stabilize that aircraft. And sometimes we get alerts ahead of time because we'll have an unfortunate captain that had to do the test run, and they will realize, yeah, there's wind shear. So we'll get alerts and we'll know, okay, we'll know what that wind shear level is. But sometimes you're the lucky one that doesn't, and you're the one that finds out there's wind shear there. So that's how you'll sometimes notice that. And this is pretty much saying with that temperature rising, if the air is cooler in the bottom and warm on the top, we'll get that inversion where it's basically the air is cool, but then in the top it gets warmer, so it starts collapsing on itself. So it's pretty much inverting. It's an inversion, so it's inverting on itself. So it's kind of the wind is kind of going in because of that temperature change. All goes back to that whole temperature change where that with the wind in play, that's how you'll also get that turbulence on that flight level here. And clear air turbulence. So basically, clear air turbulence is that air that you cannot see. And it's sometimes caused with that jet stream. So that jet stream, that wind is going so fast. So when I think of that turbulence that you get from that clear air based on that jet stream, if you ever watched that Finding Nemo, the first Finding Nemo, where he's going through that, the turtle is going through that really fast water.
The
And that's
EAC, the East Australian Current.
Yes, yeah. And he kind of falls off. And when he falls off, he gets that ripple and goes out of that water. That's literally how that jet stream is. That's how I see it in my mind. That's exactly how that jet stream is. It's just a flowing air, fast moving air, but there becomes ripples of it outside of that jet stream, and you'll get clear air turbulence. And that's basically what it's telling us, that we have wind shear here is the sudden drastic change in wind direction over a small area for a level or point to another using vertical. So it's basically what we just went over. Wind shear is just that change of wind direction. It could be fast. That's exactly what we were just talking about, but this one is a low level wind shear, which is what exactly what Brian had went through, that low level aircraft's landing and that wind direction shift dramatically, and captain had to control it. All right. So
Hey,
does
Jody.
anybody? Yep.
Hey, why don't you walk them through like things that you're looking for when you're dispatching? Because let me just add this. At SkyWest, I didn't really care too much about like trying to avoid turbulence because all of our routes were pretty short, like less than an hour almost. So there really wasn't a whole lot of things that we could do to avoid turbulence, but we spent an asinine amount of time at Delta trying to avoid turbulence. Like I'd probably say that I spend more time trying to avoid turbulence than I do like actual weather and thunderstorms. I don't know about you, Jody, but it seems like that's half my job.
Yeah.
Like we have such a huge emphasis on making our flights right. There's that aviation world. Delta Smooth is kind of the laughing that it has to be perfectly like glossy smooth when you're flying. They call that Delta Smooth because they make fun of all the Delta pilots, that complain about every single little bump of turbulence. So we spend a lot of time trying to make our flights smooth. Would you maybe go through things that you look at, things that you do to avoid turbulence for our flights that we plan?
Yeah. And that's true. We do spend most of our nights avoiding turbulence, whether it be small or big. They don't like it. So a couple of things that I do, like with that, going through that, finding that right spot, because I do a lot of those Asia flights, and so I do fly a lot with those jet streams. I do look at those jet streams, so I have that jet stream up on my chart. So that's one of the things that I look at based on where that jet stream is. I know that I might have a lot of turbulence on one side of that jet stream, so that's one of the things I tend to do. I'll look for that, and then with that mountain wave in Alaska, we have a lot of mountain waves in Alaska, and in the Canadian Rockies, there's also a lot of mountain waves there. So I tend to look at how the mountain waves are going to be in that area. Talk to Mitra about it because they'll give us all that insight with all those charts to see how that wave is going to be higher, what time they're going to be there, and things like that. And sometimes based on that, you got to figure out if your weight's going to be appropriate enough to even make that high climb over the mountains, because sometimes that mountain wave is so high that you can go above it, but you're going to lose tons of weight, or because Delta is the only one, and correct me if I'm wrong, Jaden, I don't think any of the other airlines have mountain wave routes where we have specific routes where we can go through those mountain waves. And we try to be precise in how to avoid that mountain wave and get through those mountain waves.
Yeah, it's technically a FAA route, right, to avoid the mountain waves, but we had no access. Well, I guess we probably had access to those routes at SkyWest, but we never did anything about it. Yeah, Delta, the products that we have are far superior. Also with our TPs and stuff like that, we had no other than going off of PyReps, and I guess there's some products that are built into Fusion. That's kind of our main flight following program at SkyWest that we use. There's some stuff, but really, again, most of our routes were so short. And, if you're going Salt Lake to Denver, there's really, for the most part, you're going to go straight through it. So really the only way we would avoid turbulence is to go over or under it, or, try to go around it. That's really that. So they do have those mountain wave routes for everyone. But yeah, I had no idea that it even existed at SkyWest. We'll put it that way.
Oh. Gotcha. Yeah, so we do a lot of those. And with this low level wind shear, I've actually had a few pilots going into Salt Lake City a couple of times where the wind changed dramatically and they got wind shear and they were the first ones. And one of the things that they do is they'll notify me, I'll notify Metro. Metro will put out an alert right away so that everybody else who's landing, all the other Delta flights that are landing, they'll know, okay, there's a wind shear and we need to pay attention to it. So that's some of the things. Sometimes the pilot's the one that tells us. Sometimes Metro will tell us right away with that wind shear. And with that, I'll tend to, oh, go ahead, Brian.
Just real quick, what is it? Mitra? Is that what you're saying? What is
Oh,
that?
sorry, meteorologist, our meteorologist team. I'm so sorry. So Delta has a
Oh,
meteorologist team. Sorry.
yeah, no problem.
Thanks for noticing that. But yeah, Delta does have our meteorologist team that we will go to them and they'll let us know, hey, there's a wind shear that just came out, or I'll notify them because the captain will tell us, hey, I just went through a really bad wind shear, or wasn't too bad, but there's a wind shear there for sure. Things like that. So that's some of the things that we'll do when we're going through that wind shear and going through winds and stuff like that. We try to plan very precise as to how we get through those turbulence. And does anybody work at the airport? No. Okay. Okay. No. What airport do you work at?
I work at the Provo Airport in Utah.
Oh, okay. So sometimes I don't know if that's ever happened at your airport, but sometimes our aircraft, they'll land and they'll land so hard that they'll sometimes have to get their brakes checked because the wind or whatever it is that'll get them on the ground. So they'll will have to check the aircraft sometimes if they land too hard with that turbulence. That ever happened to you, Noah, or have you ever heard of that?
I just work for a flight school, and we definitely have had to have do that. I don't know about the commercial airliners. They haven't, because we have like the radio for tower, but I haven't really noticed anything lately for that.
Oh, okay. Kathleen said that happens a lot in Orlando. Do you work in Orlando as well? And
Yeah, I work out of Orlando for Spirit, so I work
oh,
in the
okay.
operations room. So when the pilots do that, they'll call me on the radio asking for maintenance. So
Okay. Yeah. So yeah, it's crazy how
Did anyone see that video of the United flight last week that landed so hard that one of the wheels tires popped off?
oh yeah.
Pretty crazy
Yeah.
video.
Betty says she saw it. That was pretty crazy. Yeah, a lot of things can happen with that wind. It's very tricky. With that, let's take a break. Let's do 10 minutes. You guys okay with 10 minutes? What do you guys? Yeah. All right. Let me start the clock here. And we'll be back in 10. All right, everyone. Hope you all had a good break. So we're going to move on from this turbulence now, and we're going to go into air masses. And air masses is pretty much, well, before we skip that, there's a pressure in air called low pressure and high pressure. Low pressure, pretty much how I remember how that low pressure works is low pressure goes in on itself, so it's counterclockwise, so it's opposite than clockwise. It goes in on itself, so that's pretty much how that low level wind works. And then the high level where that pressure goes out, so that air goes out and it scatters that like that way. So high pressure is that way, low pressure goes in. So high, low. That's how I remember the low and high pressures. And with those high and low pressures form winds, right? Because depending on how those high pressures and low pressures, depending on how those air pockets are going, it'll cause wind because those air is moving and it can either move really fast or really slow. So that's where we get that air mass. And now with this, this is basically showing us all the different ways that we could see on a weather chart, how we could see what kind of air mass is coming in. An air mass is basically a frontal of a beginning of a air that comes in. So it can either be a cold air. So for this here, this blue one here, it's a cold front, and it's basically the beginning of that cold air coming in. So it's the frontal part of that cold air coming in, and coming in from wherever it's coming in, and we'll go through that in a second. But this is basically giving us all the different ways of how we can see it in the charts. Mixture of everything. We don't have to we don't have to learn every single one of these. We'll go through the key ones that we have to remember. All right, so air masses break down by uniform temperature and moisture characteristics. So basically, that's what we were saying, where depending on that air, that high pressure or low pressure, and how fast it's moving, that air mass will either give us a cold air and bring it in fast, or warm air and bring it in slow. And and this is basically saying that the air mass is coming from different regions of the world. The Arctic, polar, and tropical. Arctic is really cold, polar is cold as well, and tropical is warm. We don't have to memorize all that. We just know that different parts of the world have different kind of cold weather, which we all know that. And based on that, the air will come in and it'll give us that different kind of air mass, whether it be cold air mass or warm air mass, or they'll mix together and create something else, occluded air mass. And this is basically breaking down where the different kind of air is coming from and what part of the world it's coming from. We don't have to break this down. We don't have to go through it. Just know that air comes from different parts, and based on that, it'll come together and create different kinds of air and different kind of weather for us. So with those air masses, we have fronts. And this is going to be a key thing that we're going to have to remember. There's 4 types of fronts. There's the cold front, warm front, stationary front, and occluded front. Cold fronts is the boundary of cold air meeting warm air. So cold front is when that cold front moves in really fast and it overtakes that warm air. And we'll break it down in a little bit. We'll go through it in a little bit. This is just giving a general of it. Warm front is also the beginning of that boundary of that warm air, and it meets that cold air. Stationary, that's when both air is stubborn and do not want to go anywhere, and they both say, okay, we're going to stay here and mingle. And they'll just sit there because it's stationary. Stationary is the keyword. And occluded, that's very complicated. It's what the word says. It's occluded. It's occluded. So that's when it's a composite of cold front and a warm front, as faster moving cold front meets slower warm front. So it's basically a cold front meeting a warm front, and then they overtake and go through another cold front. Sounds complicated, but it's just basically a cold air meeting a warm air, and then they overtake another cold air kind of thing. If that makes sense, and we'll go through it a little bit more in detail. So this is basically how they look. And not sure if you if you have to do the symbols on your test or anything, but I would say the key thing is to know that these are the fronts, and these are the description of all these fronts. So, go ahead, Christopher.
Do cold fronts always move faster than warm fronts?
Yes.
Good, you just answered a question on my study guide. Thank you.
I'm sorry?
You just answered a question on the study guide. Thank you.
Oh, yeah. So yeah, these are the ones that these are the fronts that you're gonna have to remember. And I would say also remember the color and how they look. And with the blue, with that blue and that triangle facing down, that's that cold front coming in. And the cold front replaces the warm front, all that stuff. And then the warm front is that red line with the circular bubble on top. And that's when that warm front replaces that cold front. But that's that symbol for that warm front. That's stationary. That's when that warm front and that cold front comes together. And like I said, they're stationary. They're both stubborn, and they both just want to sit there and not move. They're pretty much having an argument, maybe for days, maybe for hours. We don't know. And the occluded, that's when that cold front comes in, overtakes a warm front, but then it brings in another cold front. So, or stationary front, I guess that's what that example is. But yeah, it's basically all those fronts coming together and kind of, sometimes you get bad weather, sometimes you don't, depending on how the air is in that occluded front. Oh, is anybody still looking at that? Is everybody good on this one? Yeah, okay, good. All right, so with warm fronts, warm mass of air and replaces the cold air. It moves about 8 to 20 knots. So it moves pretty slow. It doesn't move, it moves fast, but not a lot of fast. It doesn't always move really fast. It sometimes moves slow. And gently slopes, so warm air rises gradually along boundary. So if you see here, you see that warm air and it kind of moves over that cold air and favors broad area of stable stationary clouds, fog. So because that warm air is moving over that cold air so gradually, it'll sometimes cause fog, clouds, like the stationary weathers like fog, and it'll be cloudy. It'll just kind of stay there a little bit and sometimes end up staying there for a little while. And it'll sometimes even cause rain for a little bit when that warm air comes over and takes it over. And another key thing to remember with this warm front is that warm front could cause poor visibility. Not necessarily, not horrible weather, but poor visibility and fog and all that stuff. So that's that warm front, and that's what the type of weather that warm front brings in. Cold front. Cold fronts, dense stable air moves into and replaces body of warm air. Do you notice I'm not saying that CP, MT, because doesn't really matter. We just know that there's some air that comes from different parts of the world, and based on that, that's where that cold air will come from. But it's all we know that is that cold air, all we need to know is that cold air is moving in. And we know that the cold air is that blue frontal, the beginning of that air mass coming in. Now with this cold front, it's like exactly what this is saying. It's like a bulldozer. It comes in with a vengeance. It doesn't care. It's a bully, and it wants to take over. And it comes in with a lot of high winds, and because it's coming in so aggressive with that warm air, that's what will cause typically it'll cause bad weather for that cold front. But once that cold front, so once that frontal passes, it'll then bring calm weather, because that cold air, it's just the beginning of that frontal boundary, right? So that, remember we were talking about that air, when different temperatures of that air, that adiabatic process works, it all comes together, and that is what causes that cold and warm mixture of getting thunderstorms and everything, because it's all developing so fast. That moisture is building, those clouds are building, and it'll just become really bad weather. But then because it's all cold air, then stable air coming in, it'll then become calm. After that weather passes, after that front passes, it'll then be calm. But at first, it'll be thunderstorms, and it'll move fast. All right, stationary. Like I said, these are lazy guys. One says, I don't want to move. The other says, I don't want to move either. So what do? It'll cause like a slower process of that cold front that comes in, right? But it's just slower. It might not, it's not even going to be that drastic as the cold front coming in, because they're both stable. So depending on how those two mix together, if they decide to not play nice, it might rain for like a couple of hours, because those two frontals are there and they're both arguing, saying that they're not going to move. So they'll just sit there and stay, and it'll be cloudy for hours, or it'll have rain showers for hours, and sometimes days. You never know. You never know how long they want to sit there and duke it out. But that's pretty much what that stationary front is. It's two weathers, two masses, the cold and the warm mass coming together, and they'll sit there, and the weather will be there for a while. All right, the occluder front. This one, it's not really sure how to explain it very much, so we're just going to read from the board here. So forms when faster moving cold front overtakes a warm front, merging the two. So remember where I said earlier where that cold front comes and takes that warm front, but then they merge, and then they'll overtake another front. So then the clouds precipitates can occur in the area of frontal lift. So frontal lift, so when that first cold front meets that warm front, there'll be weather there. As fronts approach, warm front weather prevails, but followed by cold front weather. Two types, cold front occlusion and warm front occlusion, which is the cold front, depending on which front takes over the other front, if that makes sense. I think we have a picture here so we can look at it. Let's see here. So yeah, this is what it basically looks like. So it's that cold front overtaking that warm front, and then they meet again with another cold front. So it brings in an occluded type of weather, and with that, that weather will sometimes be rain, cloudy, because of that mixture of all the different type of fronts coming in together. So basically, let me see how I can, so with this, because of that, that frontal of winds with that high pressure, cold, warm, and all that, it can sometimes cause low pressure and high pressure, which is what we were talking about before with that low, that high, where that pressure, that wind will move out and go outwards, but then that low pressure collapses on itself and goes inwards. And sometimes they'll come together and go into each other, which will cause sometimes thunderstorms and things like that. If you could see here, that conversion of that cloud, which is basically that wind going up in that cloud and then causing a lot of thunderstorm, and that diversion where that wind is going down. And with the diversion, you don't get a lot of weather, but when they combine, if they're close to each other, they could cause a lot of mischief and not be good. So let's see if, I believe they were on the first. There's a picture on the first here. So, I mean, with these chart, it doesn't show any close together. These are all showing scattered. They're all the low levels and high level, high pressure is all scattered. But when they come together, like if these go closer together and they start building with each other, that can create a lot of weather havoc there. And this is basically showing the same thing that we were saying with that cold front and that warm front moving in together. And depending on how those cold front and warm front meets together with the wind, it'll cause a low pressure versus a high pressure. And you see that circular here with that low pressure, because it's going in on itself. That wind is coming in, so that cold and that warm mixed together, and that is coming in on itself. So it's that wind is coming in and it's developing low pressure. Now the dry line, this is basically saying with that dry line, with that warm pressure and that cold pressure coming in, there's sometimes a dry line between. It typically happens in Texas area, where we have dry areas where they mix. When they mix and they combine, because that warm and that cold come together, which is bringing in, one is bringing in dry air, one is bringing in moisture air. They come together, they can cause big, huge thunderstorms, different kind of weather phenomenons. That's where that danger lies, and it normally happens in that Texas area, stuff like that. So that's where that dry line between that, where that line between that moisture and that, that moist air and that dry air, because that moist air is coming in from one side and that dry air is coming in from the other side, which is the West Coast, and then they just come together, and with that wind together, because we need that, with all that, it brings in unstable air, and it'll bring in a lot of moisture, and those are key factors for thunderstorms and weather phenomenons. Yep, which is us going into thunderstorms. It's thunderstorms. They produce cumulonimbus clouds, and brings in lightning and thunder, all that hazardous stuff that we don't want to fly through, right? So this is pretty much what they're telling us, the three main factors for thunderstorm. This is also an important factor for you guys to know. For thunderstorms, the three main ingredients. So we have moisture, right? Water vapor. So that water comes in and it rises, it creates a lot of moisture in the air. And that lifting, the convergence of like that wind coming in, going up, all those lifting with that moisture, and then that unstable air with that pressure of that air pockets coming up, and depending on how they come up with the temperature outside versus that air pocket, it can either be really bad or not too bad. But these, if they all combine together, that moisture, that lifting, and that unstable air, we're guaranteed to have thunderstorms. So main things to remember. And this is just basically telling us the cycle of that thunderstorm. Starts building, we have that moisture, we have that instability air, and lifting. That lifting mechanism just keeps lifting and causing cumulus clouds on top of each other, top of each other, top of each other, until it creates a huge, huge cloud until it bursts, can't take it no more, and starts getting, you have that updraft of wind, and then that downdraft of that that rain, because that cloud is packed with so much moist, it starts coming down. And then we have the dissipating, where it's still raining, but not as much. The cloud is losing a lot of its moisture, so it's kind of going away a little bit. That cloud is emptying out a little bit. So that's pretty much the cycle of a thunderstorm. And this is basically saying there's 3 major types of thunderstorms: singular, multicell, and a supercell. Pretty much all are hazardous. Well, we don't want to fly through any thunderstorms because it can cause stuff like hail. You know, it's just all things that we don't want to be in when we're going through thunderstorms. So, which is one of the key things. If like I'm planning a flight and I see there's thunderstorm areas, sometimes it's not even fully developed, but talking to Metro and meteorologists, and our meteorologist team will tell us, hey, this moisture is, the moisture in that area is developing. So later on, there is a possibility of having thunderstorm. Even if there's, and sometimes they'll say, you know, it's sometimes it might not develop, but it looks like a possibility of developing. We tend to just avoid it. So those are some of the things that we will look at when it comes to these kind of thunderstorms. So if they're like, oh, the meteorologist says, oh, there's a possibility that we get some more moisture in the air, so we might have more thunderstorm. It might not happen though. We typically just say, okay, we're just gonna avoid it overall. We're not gonna risk it. Has anyone ever flown and seen thunderstorms while they're flying? Like you're in the aircraft and you just see it flying by. Betty? Okay. Brian? Okay.
No, I don't.
Uh,
Korean Air makes sure we are very, very safe, smooth. Yes.
okay. Yeah. Sometimes we'll be flying next to the thunderstorm, so you'll see it on the other side. You'll be flying parallel to it sometimes, and you'll see that cumulus clouds, and you see it light up like a light. Especially at nights. One time I had to do my jump seat, and I saw the cumulus clouds. I was like, oh my gosh, it's like a Christmas tree in there. It was just lighting up. But yeah, it's pretty cool to see. Not to be in it though.
Yeah, that's right. That's right.
I have a video on my phone of when I was in the jump seat looking at thunderstorms ahead of us and around us, or I guess not around us, but still far away. I'll see if I can find it. It's pretty crazy.
Yeah, it's pretty cool seeing it. Anyone else ever seen that thunderstorm while they're flying? No. Oh, oh well.
Right.
Christopher,
I'll see if I can share my screen.
okay.
Let's see if
Christopher,
this
you've
works.
probably seen a lot.
Oh yeah.
Especially flying in the desert in late summer and fall, you get
Oh yeah.
the thunderstorms moving through.
Mm.
They are beautiful as long as you're not in them.
Right, right. It's nice to see from far away.
Oh, hold on. Not showing up. Okay. Let me try this one more time.
Is it not working? I mean, what we saw was good though. I saw it. I don't know. Did everybody else was able to see it? Yeah, I think so.
Yeah, for some reason it's not working, but it was like solid lightning for like 2 straight minutes, and that's how it was for
Oh,
like
wow.
an hour, hour and a half in flight. It was amazing.
Yeah. Yeah, that's pretty cool. That's how that's pretty much how I saw it when I was in my jumpsuit too. That's pretty cool. All right. So it's pretty much the same thing we were talking about. Get that building of that uh cumulus clouds, and then we get that mature stage where it's just can't hold anymore, and then starts doing that jump down drift, and it's letting go all that water, and it starts dissipating. So this is basically talking about the downburst and the microburst of the clouds. Intense downdraft, and the thunderstorm produced downburst, which creates strong, sometimes demanding winds and wind shear responses for many low-level wind shear accidents. Smaller, short-lived downbursts called microbursts. So one's longer and the other one's shorter. So it's basically that downburst of that rain coming down, and the microburst is just a smaller amount. So basically, with that downburst of that wind or that rain, or it'll, well, in this case, wind, we'll see. This is basically an example of how it can affect our aircraft for flying, and you suddenly get that air coming down, starts flying. So he's trying to compensate. That aircraft is trying to lift a little bit, and then gets in the middle. That aircraft just, that wind just brings him all the way down, and then he's trying to compensate, but then that wind changes again, and that aircraft kind of loses its stability, and we can crash, which is why we try to avoid it as much as we can. All right, supercell thunderstorms, pretty much long-lived. Of course, it's huge. There's a lot going on in there, so it's gonna take some time to get rid of all that rain and that moisture. So it's just a convective storm that just keeps going, and it'll just rain for a while. And so that updraft can reach up to 100 knots. All right, so nearly all of them produce severe weather, and like I was saying before, it has with these thunderstorms, in this particular one, a supercell thunderstorm can cause hail and high winds, very, very high wind. And I guess this can also sometimes produce tornadoes. Well, 25% of them produces tornadoes.
Speaking of tornadoes, just a couple, I guess, about 2 weeks ago, we just had a tornado that touched down. Like I was taking my dog for a walk, and the siren started going off. Um, you know, surprisingly, get that a lot more than I thought we would in Georgia. So happens a couple times a year where we're got this tornado siren. There were about 5 years ago, there was an EF4 tornado that went through the town that I was in Cookout. Did some pretty good damage. So no fun.
Wow. Yeah, that doesn't sound like fun at all. And this is the cyclone, which is basically the thunderstorm that's really bad. Get those high winds. You get those real bad uplift and downlift and all the fun stuff that we don't want that can create a lot of weather phenomena with that tropical cyclone. And that hurricane structure, which we went through in that eye with that storm, but we honestly don't need to know the layout in full detail. We just know that there isn't moist air, uplift, and instability of winds. And this is basically a category of hurricanes and how much the winds are with our hurricanes. So category 1, we have 74 to 95 miles per hour. Category 2, 96 to 110 miles per hour. Category 3, 111 to 129. Category 4, 130 to 156. And category 5, 156 miles per hour. Actually, with that Hurricane Melissa that had hit Jamaica, luckily nothing happened, but our house was kind of like category 3 by the end. It was almost, well, actually category 4 because our roof went out in category 4. So yeah, it's pretty crazy. Don't want to be in those kind of hurricanes there. Anybody ever been in a hurricane? No? Yes. Go ahead.
Yeah,
Oh, wow. Yeah, go ahead, Brian.
yeah, I grew up in the Houston area, and I went through Hurricane Alicia in 1983. I was 8
Oh.
years old,
Oh my God.
and that's what I'm a big meteorology buff, mostly because of that. That's what kind of started it out. It was terrifying and fascinating all at the same time.
Oh my goodness. That's pretty cool. Some experience. Some people go through that and they'll be like, I don't even want to know about it. I'm terrified, traumatized, humidified. Like, don't even bring it up. That's pretty cool. When I was a baby, I went through hurricane. Oh my gosh, and now I'm having a brain fart. I don't remember the name of the hurricane in Gilbert, but I was a baby. I don't remember it at all.
That was a bad one.
Mm-hmm. Yeah, that was a bad one. And that's pretty much how that cyclone looks on the radar from the equator. But we don't really need to know that. And Jaden, I think we're through the slides.
Yeah, so take a look at that. That's pretty amazing. We think we get them pretty bad in the southeast, but look at Asia. I know that's kind of a hard map to look at because there's so many tracks of hurricanes and typhoons on there. But I know us as Americans are like, oh, we get the worst. I walk uphill both ways to school in the snow, you know, la la la. But y- they're significantly stronger over there, and right in Asia, you can see basically that those purple colors are almost non-existent. So pretty crazy considering all the, you know, obviously we've kind of more focused on the ones that kind of directly affect us. There's a lot of crazy. Have you guys seen the Hurricane Hunter aircraft flying? I love, you know, being an aviation nerd. I always like track all those C-130s that fly in and out of the hurricanes. And like, man, that would be so terrifying. You know, there's some pretty good videos from. Can't remember what the storm was this last year, but they're, you know, someone was in the cockpit and they're just taking the videos and how they're just like literally shaking. I don't know how the you know, all the bolts and rivets of the airplanes, you know, stay as you're just going back and forth in and out of the eye walls of the hurricanes. It's pretty amazing. But what was I gonna say? I had a mention something else about hurricanes. Now my mind's blank.
Actually, to piggyback on that, one day I had a really interesting day where I had typhoon in Taipei, and then I had volcanoes erupted in Russia, and then I had because of that because of that volcano, I had oh my gosh, why am I drawing a blank of when that waves from the water comes in Hawaii?
Tsunami.
Tsunami. All in one night. That was a fun night to plan. Is that a question? If you like, if I was going through, I planned around it. I had to plan literally around all of those stuff. So my flight was about an hour over than the original time it was supposed to land, but we had to plan through all of that and all that weather. You weren't sure how long each was going to be going on, so you had to take your time to plan through all of those different weathers. So that was a long night for me to handle.
Yeah, most of these severe weather events too, other than like a hurricane, you know, are most of the stuff you're trying to plan on the fly too, you know, like right, they don't forecast where tornadoes are going to go. Sorry. You know, they don't forecast where tornadoes are, so you gotta kind of go on the spot. There's a pretty cool video happened this last year of a tornado going right through the Kansas City airport. Did anyone see that? There's people that were literally sitting on the plane and they're videoing it from the window of their seat on the planes. See the tornado going through in the distance. Pretty crazy. And you know, obviously we can't plan around that. We try to plan around most of stuff. Hurricanes, you know, a lot of people think that, oh no, you can't fly in or out of a hurricane. Well, I hate to break it to you, we do it all the time. Unfortunately, Delta prides itself on being the first one in, last one out mentality when it comes to storms, which is, I mean, obviously, you know, we maintain the safety of flight, but we will push it. Not necessarily in a bad way, push it, but you know, other airlines will have ceased operations and will continue to, you know, keep going, trying to get people out of areas before storms will hit, and then shortly after trying to operate as soon as possible. You know, we fly through, you know, with those hurricanes, they have large rain bands that are on the outside of the hurricane. We'll fly through those rain bands, no problem, you know. I spent a lot of time doing flights down to South America and the Caribbean and stuff like that. So I've dealt a lot with the hurricanes in the Caribbean, in the Atlantic, and you know, we will fly through like there's no tomorrow. So we stay out of the tricky spots, but you know, we'll still continue to operate. So again, a lot of this is on the fly, but as this weather develops, you're consistently monitoring the weather, gauging, right? Is it still safe to operate? If it's not, pull the plug, right? Obviously, you always have a backup plan. You know, even when there's good weather, you always need to come up with a backup plan, game plan. You may not, now that may not be like always carrying an alternate per se, right? But you know, okay, if something happens, I'm going to go here, you know, or I'm going to plan enough fuel, even though I don't have an alternate for, let's say, Miami. But you have enough fuel that you can get to Fort Lauderdale or Palm Beach or Orlando or something like that in your back pocket if something worse comes to worse, that you are flexible. Because weather, again, is constantly changing. It may develop exactly as it's forecasted. Most of the time it doesn't, right? We talked about yesterday where we kind of play the game of BS, right? We look at the TAF and kind of have to read between the lines and figure out what it's going to be. So it's important for us to be flexible, have backup plans, and be able to adapt, turn on a dime when plans change. You know, that's really where we add value as dispatchers. Right? We're not there for the good days, right? They can have software that could replace us. You know, it's kind of like pilots, right? Pilots aren't there for the good days either. They're there for the bad days and when things go wrong. And that's to the same degree how dispatchers are too. So, you know, we're there to adapt, look at things, flag things, pass along that information with those ever-changing weather conditions. And, you know, keeping our flight safe, keeping our passengers and our customers safe is our ultimate goal. So, yeah, Brian, did you have a question or a comment?
Yeah, I was just going to ask if you get like when it comes to thunderstorm development, do you guys like do you often check like the Storm Prediction Center? Because you know how they'll issue like these mesoscale discussions when they're like, you know, where they actually kind of outline an area where they think there's about to be thunderstorm development. But it just seems like, because that's kind of a, you know, very short term, you know, usually like if they think something's going to happen in the next hour or so, they'll issue a discussion about it. And it just seems like that could be really useful if you've got going to have flights going through certain areas.
Yeah, so our main tools that we use for thunderstorms, and I'm sure Jody can elaborate on this a lot more, but maybe Jody, you could even, well, I was going to say maybe you could pull up COSPA, but there probably isn't anything out there to show. But we use a product that MIT developed and maintains. It's called COSPA. I can't remember what that stands for. Way too many acronyms to keep on track of everything. But we primarily use COSPA. That's kind of like the Delta kind of bread and butter when it comes to forecasting thunderstorms. We also look at the TFM convective forecast in aviation weather, and those forecasts will kind of outline areas where there's expected to be convective development. And so those are kind of the two main areas, along with our meteorology department at Delta will issue, they have their own kind of threat advisories that they set out. They call them threat plots, and they will kind of put, again, areas where they'll highlight that is high likelihood of convective activity. They'll give us times, they'll give us expected top heights of where those cloud heights are going to be, movement, stuff like that. And so those are kind of the three main things that we use when it comes to convective forecast. So, and then we can use as far as like long-term stuff, looking farther out. Another tool that we like to use is called Tropical Tidbits for looking at what's, you know, going to happen several days in advance. I'll look at that kind of like at the beginning of my work week and say, okay, what am I going to deal with this week? You know, see if I need to call out sick any days, you know.
Looking at like the computer models and stuff.
Yeah. Like, so for example, we've been looking a lot about that because We had this ice storm that just came through Atlanta this last weekend. And then on Monday, they're projecting another round of snow and storms to hit this next weekend, this upcoming weekend. So we've been following that closely to see on Tropical Tidbits to see what, that's going to be looking like. So we'll use that for farther out stuff. And then we use other products for other convective areas throughout the world. There's OPC that we use for like South America, Caribbean, and we can use in different other parts of the world too. Once you really kind of get out of North America though, the tools aren't there to forecast thunderstorms very well. So like even in South America, it's a shot in the dark. Like we have kind of an idea, right? You're gonna have thunderstorms develop along the ITCZ. There's always going to be scattered thunderstorms there, kind of around the equator every day. But really, the forecast tools for South America just are not even remotely as developed as they are for North America. So all we can really do is our meteorology department will kind of, again, give us some ideas where those thunderstorms will be. We'll try to avoid those areas that they tell us. And then we have to simply just add some extra fuel on our flights. And a lot of times the pilots will just kind of have to figure it out as they go, and we can give them directions. Hey, it looks like, going to the west looks best, or, and give them ideas as they're flying. Again, that's kind of where we can bring a lot of value as dispatchers. But yeah, there's sometimes weather, all you can really do, you plan the best, but you just got to add some fuel, and we figure it out on the fly, unfortunately. So, but great question.
I don't know if you guys could see my screen with the weather on there or no.
We just see the PowerPoint.
The PowerPoint.
So.
All right.
And speaking of, we'll go through some of those tools tomorrow, Brian. I'll kind of show you some of those weather charts, unless Jody wants to show you some of those tonight that we use. OSPA is an awesome tool. They'll give you access to it. Again, it's an MIT product. We can go through this tomorrow, but if you email them, hey, I'm a dispatcher, I'd like access to it, they'll set you up an account and give you full access to it. So it's pretty cool.
Yeah. This is kind of what some of our weather stuff. I for some reason I can't get COSPA on my home computer. I can only get it at work. I can never see it on here. But oh, here it is.
Jody, why don't you run through some of those, all those kind of things that Delta has specifically, and run them through TPs and turbulence, and kind of look at what's out there, and show them kind of how you plan that way based on what's going on.
Yeah, let me try and log in to this one here at COSPA, and see if we can go from there. All right, so this is basically one of the tools that we use at Delta. This is when I'm doing domestic flights. This is pretty much how one of the tools I would use to pretty much see how I will be able to work my flight that day. like Jaden had said, there's other tools, but this is one of them that we would basically go through. There's a time lapse, so you'll kind of see what weather it is. But today it looks like it's a beautiful day to be working. I should have picked up overtime. But this is pretty much what we'll look through and see what kind of weather we're having. If we're gonna have any lightning and stuff, it'll pretty much come up and it'll show us, like here, for example, it shows us the tops of the clouds and how high that cloud is going if we can fly over it. And sometimes it'll go up to 400. So with that, you can't really go over it. But this is like a pretty good tool. It'll kind of give us a pointer of, okay, where will the thunderstorms be? How will I be able to fly today? Do I have to fly around some weather? Things like that. Kind of also shows, like I said, today looks like it's a pretty good day, so we don't really have a lot to show on here. So but yeah, this is pretty much how it looks like, and we'll do a timeline of how, and sometimes you'll even go back to see how that weather was moving to kind of get a better idea to see, okay, it's been stable. It looks like we can try to predict that that's gonna, for example, this right here, we can predict like, okay, it looks like it's been stable in that area. It's not, the wind isn't taking it too crazy, but it looks like it might dissipate. It looks like it's dissipating a little bit. So we can plan to fly in that area after a certain amount of time, things like that. Yeah, this is one of the tools that we use, which is pretty cool. There's also there's a multiple. This is also where we can see our volcanic stuff, but won't get too much into that. Icing. See what that's what this. So this shows all our icing in the with our time lapse as to how our icing is going to look. How much icing do we have in each area? So pretty much we have an aircraft that it takes out their going through icing. The maintenance calls and says, all right, so we can't take this aircraft through icing. You'll basically, depending on where we're going on the map, you'll know, okay, can't go northeast because there's icing conditions in that area. So definitely wouldn't be able to take that aircraft if we're going in that area. Or here, west, wouldn't be able to go in that area because there's a lot of icing. And if your aircraft can't see that icing, we're not going to go, right? You can't take it, so they'll swap your aircraft with another aircraft so that you can go into icing conditions. Things like that based on the icing. And it looks like here we have some thunderstorms out in the water here, which for here would be our Sydney flights that would be going through here. So they would have to fly around that area so that we have a smooth ride, because Delta flies smooth. So things like that. Let's see, the Caribbean looks pretty calm. Oh, yeah. And that, I believe that right here, that's like severe icing. So would definitely try to avoid those areas if we had icing through that area. And this is basically our Pacific. It doesn't really give a lot of accurate, like what Jaden was saying, when we're outside of the US. So if you notice, when we're outside of the US, it doesn't give us a lot of accuracy when we're outside of the US, we rely a lot on our meteorologist team when it comes to flying internationally, but domestic wise, today looks like a pretty good day. Let's see what other tools I can show you here.
Is just real quick, is those white outlines, is that the ATC centers or what is?
That's
are
our these
What are
right here,
those?
right? You're talking these
Like-
right here.
Well, I'm not seeing your pointer. I'm like
Oh,
on
sorry.
on the map of the United States, it's got like several groups of states or regions kind of, outlined in a white, in, different sections. I
Yeah,
was just curious as to what that was.
the outlines of the map, like
Yeah.
Yeah,
like-
those are ATC centers.
yeah.
Oh, okay. Okay, cool. Yeah.
The
Thanks.
blue lines are the states. Yeah.
Yeah.
Thanks. See what else we can look at. So these. Hold on one second here. And you guys could see the icing in that. And see how the icing moves. Oh, wait, you guys can't see it. Hold on. Yeah, there we go. You guys see you guys made me talk about this icing and nobody said, hey, Jody, we don't know what you're talking about. You know what? Epic fail on my part. My apologies. But I think you guys are enjoying making a show of me now. But anyway, this is what I was talking about before when the map was not on it, where we could see the icing conditions and see how the icing is moving through the map of the United States, and seeing that we can't do icing in the Northeast area and the West Coast, all that. So that's one of the things that one of the systems that we use there. And let me see if I can find another one. This one I believe I showed before. I'm not sure if I did, but this is basically showing our turbulence and how you guys could see the map with the turbulence, right? Please answer me this time. Yeah, great. With the white boxes, with the flight levels, great. So this shows our flight levels and how our what flight levels these light to mod turb is, and what to avoid in that flight area. So look like it's all light to mod. So when it's light to mod, it doesn't really we can, if we have no other choice, if it's gonna affect our flight plan where we're gonna be an hour, 2 hours late just to avoid a light to mod turbulence, we tend to go through it and we'll just tell the captain, hey, there's a light to mod turb, and the captain will he or she will tend to go through that area. If it's too rocky, where it's too much of a mod turb where they can't stay in that area, they'll tend to try and find another flight level, which is why we would put more gas on our aircraft, because things like that we would have to plan it ahead of time, because as dispatchers, those are our duty to make sure we plan for the unplanned, right? Because if that light to mod turb becomes moderate turb, we have no choice but to either fly super low or super high, and we would need more gas to do all those things, right? So when we're thinking about these turbulence, those are the kind of things that we kind of have to think about when it comes to the turbulence in the air, and that's one of our main reasons why we look at these turbulence, right? To make sure that we can plan ahead of time and plan to things that might not sometimes that could go wrong in that specific scenario. So for example, this turbulence right here, it's flight level 26 to 260 to 310. If our aircraft is light enough where we can fly over that, we'll just profile it to fly over that, right? We wouldn't have to worry too much about it because that flight level is so low. Now this bad boy, we have a light to mod where it's flight level 330 and to flight level 370. So from flight level 330 to flight level 370, it's all turbulence, right? Now I would have to be able to get to flight level 380, 390 to be able to go over that. But if I can't, I'll have to go between that flight level. So that sweet spot would be like flight level 320 or even 310. Does that make sense? Because that turb is in between and we're going to try to find that sweet spot. Sometimes now there's some pilots that are like, no, I'm not doing that. You have to plan around me. You have to plan me around that. But most of our Delta pilots, they understand the assignment. So they'll be like, all right, we got it. Just make sure I have enough fuel. They love to just carry. As long as you give them a lot of fuel, sometimes they'll be like, okay, we'll take it.
Yeah, we call it comfort fuel.
Yeah.
Kind of like a comfy blankie, you know, that you have comfort fuel. So surprisingly, captains are a lot more happier and can actually do things. Okay, don't take this in the wrong way, but you know, if they get an extra 500 to 1,000 extra pounds suddenly, now all of a sudden they can do it. You know, they'll call and complain, and you know, not that we don't trying to like have them flame out or anything, but it's our job to kind of keep the costs down whenever we can, right? Use fuel when we need to use fuel, cut back and be economical when we can, right? That's part of our job too, saving Delta money and your airline money as well. You know, whenever there's a valid reason to have fuel, awesome, but don't just add fuel to just add fuel. You know, yes, complete the mission, but don't. You know, there's no. It costs money for fuel, even if you don't burn it, right? It costs money, and you burn fuel to take fuel, right? So there's a cost involved with that. So, you know, we have to be mindful of that. There's particular fleet types that are worse than others. For some reason, the 737 fleet at Delta is extra whiny. We'll just put it at that. They're really particular. They have like a specific number of fuel that they want to land at. They want to land with exactly 6,500 pounds when they land, and if it's not exactly that number, then you know they get mad at us as dispatchers. So there's some particulars with that, but you know, we do our best to complete the mission. Like Jody was saying, go around turbulence, go up or below, and save fuel where we can. But anyway. And you get double points if you're a 737 Seattle-based captain. They're probably the most whiny out of everyone.
Yeah, especially leaving out of Hawaii. I do not know why they think light turbulence is the worst, and they don't want to go around it. I mean, they want to go around it. They don't want to go through it. But yeah, thanks for elaborating on that. But yeah, this is basically how our turbulence, like I said, there's not a lot of turbulence going on today, so unfortunately we don't really see much. But another cool thing I think our Delta meteorologist team does is they'll tell us where we're getting that turbulence from, so you'll see exactly why we're getting some of those turbulence. So this turbulence here, it's in that tropopause, so that's why it's at 370 to 410. So they don't just say, oh, light to mod there. It doesn't matter what it is, they'll tell us exactly as to why each of these turbulence are happening, so that we can all be on the same page. Because sometimes these pilots, they'll be like, oh, why is it showing turbulence here and I don't see anything on their radar? Because sometimes they have a widget weather that sometimes doesn't work very well. So they'll sometimes ask us in details what's going on ahead of us, and these are some of the things that'll give us better insight to let them know exactly what is going on, so that they know that we're watching them, we're all on the same page, and we see exactly what's going on. Let's see, another cool thing here. There's no warm temps here. Let's see. No warm temps, but nothing to really worry about here. But these are warm temperatures where that same in certain flight levels. So in this case, 330, 350, 370, and 390, we have warm temperatures. Sometimes these warm temperatures at a higher flight level can affect the way how our aircraft perform as well. Even though it's not on the ground, weather is strange like that. Remember how we sometimes have different temperatures in different flight levels. The pressure in the air is different. The different flight levels show different temperatures. So that's a prime example of how we'll have different temperature, even though that's flight level 35, 37, 39, it's warm up there. And because that temperature is warm, our aircraft can be different, can work different within that that flight level and those longitude and latitude. So you'll know if you're planning that flight, you have to make sure that that pilot going through that flight level is going through it, and his aircraft can make that performance. Let's see.
Show them TMS.
Oh. Hold on here, TMS. Oh yeah, it's a good one. Oh, it's not working on mine. Hold on. And it doesn't load on my on my home screen. But TMS is basically where the pilots, it's another website where the pilots will tell us what kind of turbulence is going on out there, and it'll help the pilots behind them to know, okay, this is that. So for example, let's go back to our TPs. So it'll say that TP is actually light, or at that at flight level 310, that TP in this area is actually light. It's not moderate, it's not too bad. So they'll report at that specific point that TP is light, so the person behind them can say, okay, we can fly through it, we don't have to worry about it. Or they'll be like, oh, I don't want to go through any turbulence, we're going to go above it, we have enough fuel for it. So that's what that TMS website that Jada was talking about. Unfortunately, I can't pull it up here at home, but that's also
Yeah, it
another.
actually, it's not necessarily, there are pilot reports, but each one of Delta's aircraft is equipped with an EDR sensor. If any of you guys are familiar with that. And it's what is it, eddy dissipation rate, I believe is what it stands for. Correct me if I'm wrong, but it basically goes, all the aircraft have these sensors, and it has like an accelerometer, and it senses G-forces. And so as it goes through turbulence, it gives it a specific rating out of 6. 6 is like the worst, right? You're hitting severe turbulence. And then, 0 and 1, obviously 0 is none, it's smooth, and 1 is getting into light turbulence, and so on and so forth. So because turbulence is very subjective, right? Moderate to one person may be extreme turbulence to another, right? That's not as experienced. So basically what that takes out the whole human factor of the turbulence, and it just is what the aircraft is actually experiencing, and that's called the ADR. So as the aircraft are flying around, they are constantly, every so often, sending out a signal, sending out an EDR. So there's all these EDRs all across the country from Delta Aircraft. I believe Southwest it does the same thing, and we share all that data between Delta and Southwest, and there may be some other airlines that do it as well. But so we get all this real-time EDR data from the aircraft telling us exactly how, right, severe or light or moderate the turbulence is based on this rating. And again, that kind of takes out, man, that was the worst turbulence I ever had. I haven't had turbulence that bad my whole career. And some guys like, yeah, that was nothing, right? I've been doing this for 30 years, and that's nothing close to the worst. So it kind of takes that aspect out of it, and it just kind of straight is exactly how much the aircraft kind of shakes, right? That's what it senses. And so then we can kind of get that real-time data, and we get reports all throughout the country. Because the other downside of the pilot reports, which are great, and our pilots are pretty good about giving us reports, right? Letting us know when it's not smooth. However, right, it's kind of up to them how often we get those reports. And the aircraft is doing it itself with these EDR reports. So we get a lot more reports because it's just kind of an automated process and system that's continuously sending us that information. And so we've got lots of great data points that we can send to our flights. Hey, a flight just went through this area at 320. They reported smooth, and we can send that on to help us find where we are. Because again, these turbulence forecasts, they're just forecasts, right? Again, we gotta have to read between the lines. We have to kind of take what the actual conditions are as they're happening and make split-second decisions based on that data. And so sometimes forecasts are not right, sometimes they are, but we look at that current data, we're constantly monitoring, going through that so we can send the most up-to-date, right? Monitor the progress of the flight, issue that necessary safety information for the safety of flight. And we're constantly doing that over and over and over 1 million times again a day. So that's just kind of a cool tool, and just helps us to get a lot more reports of turbulence, and that helps us to better forecast turbulence, right? Because we have all of these data points from all of our aircraft flying around the country, and they can say, okay, this aircraft in these situations, in this circumstance, typically has this type of EDR rating, right? And so then they can say, okay, in the future, when we get that, this is kind of what it's going to be like, and this is what we can expect, so we can better plan for the future. So it's just, again, helps us collect data, distribute it, and helps us make a lot better informed decisions. So
Thanks, Jada. Just trying to go through all these and see. Here's where temperatures. We can see all the temperatures.
yeah, I wish I was in Miami today.
I know,
80
right?
degrees, and everywhere else in the country is like way too freaking cold.
Right. Oh, here we go. Here we see the high pressure and the low pressure. And can somebody tell me what are these ones? Or can somebody just give me like a brief of what the colors are? Oh, yeah. Oh, yeah. Can somebody kind of go through what these colors are so we can kind of review of what these are? It doesn't matter if you okay, Tatuman, is that how you say your name?
It's Tatum. Just kind of ignore the
Oh, I
M.
totally messed that up. I'm sorry.
It's okay.
Timan. Okay, so while I have you here, Timan, can you? Okay, so I like this. You got cold fronts are the blue, which is great, and warm fronts are the red. That's great. So do you remember what the blue and red combined are?
Stationary fronts.
That's right, exactly. Stationary fronts. It's great. And do you remember what the purple ones are?
Occluded.
There you go. Great. So with that occluded, we have that mixture of that cold coming in together with that warm, and then getting more of that cold front, so it all becomes all together. Can anybody else tell me what kind of weather comes with the cold front? Just take a random guess. Doesn't even matter if it's wrong at this point. Let's just talk about it.
Well, okay, go ahead, Caitlin.
Oh, sorry. There's usually thunderstorms and the air is moving pretty fast. So not great weather, but then it will calm down later.
There you go. Great. That's good. At least you guys were listening to that, not the part of me not doing the screen right. That's good. At least we heard the important parts. And what about the warm front? Can anybody tell me what kind of weather comes with that warm front when it moves in?
You typically have stratus type clouds, steady rain, lower visibility, and it lasts a little bit longer.
Yeah, right, because it's a little bit slower, so the temperature just kind of gradually forms, and you kind of see it coming because you kind of see that cloud building. Good. Can you tell me how that low level? Somebody else, you don't have to answer this, Pete, but can somebody else tell me how the low pressure moves? Like, how does that low pressure moves? Ryan, go ahead.
Anti-clockwise.
That's right. And it moves in on itself, right? Because it goes in. It's right. Perfect. And can anybody else tell me how the high pressure works? Okay, let's do Caitlin, because Brian, I like your attitude, but we're gonna let somebody else answer since somebody else.
I can wait. I just didn't
No,
want
no, 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 no.
Okay. It moves clockwise and out.
There we go. Yeah, clockwise and out. Clockwise and out. Great. That's good. And these are the I don't know if we went over a little bit, but these are like the isobars. And these will kind of tell us how much that wind is moving. The closer they are, it kind of tells us how windy it is in that area. And the farther out it is, it's not too windy. So, of course, we're here in Atlanta. There's not a lot of isobars, so it's not really windy today, right? So, yeah, it's pretty much a good example of what we just went over. I like it. All right, so actually, it's almost 10 o'clock. Do you guys want to take 20 minutes and then we can come back and all right, perfect. Let me put that 20-minute clock on for us. Oh, no, not 2 minutes. Oh. Well, not. We're going to cancel that. There we go. Okay, great. Now we know how to work the clock. All right. Hope everybody had a good break. Had some good food. Take a 10-minute nap, 5-minute nap. All right. All right. So for the last, good. I started my laundry because this is my daytime. I work midnights, so this is the start of my day pretty much. I work from 9:30 p.m. to 6:30 a.m. So I'm in the prime of my day now. So started laundry. Probably work out after this, you know. Get my day going. Thanks for asking, by the way. All right, so the end of our time here, we'll probably just, not probably, we'll just do some reviews. We'll review all the things we went through and try to go through some of the things that I was looking through the study guides that you guys have to do. Study for your test and stuff like that. So going through all of that, I figure we can go through some of them and do some review. So that way it can help you guys to get you guys on the right path. All right. Let's see. Just waiting for everyone to get back so I don't start and then someone missed it, because I would hate to miss some of this. This is the juicy part. This is the part we don't want to miss. All right. I'm not going to go through everything on the study guide because obviously I did not go through everything with you guys, but I'm going to go through as much as I can so that I can leave you guys with as much knowledge as possible so that we can ace this. Okay. Because honestly, you go through all this dispatching. I don't know if everybody here is planning to do dispatching. Is everyone here planning to do dispatching after you do this? Because I know some people want to just do the license just to have it. Yeah. Oh, good. Cool. So, but yeah, after we go through all this, half of the information you might still not even comprehend. You're probably just like, I don't know how I even passed that, but you did it, because I'm pretty sure everybody's going to pass it. But after this test, you guys are going to go through even more tests, and then more tests. And then when you guys all get to a major airline, guess what? It's more tests. And then when you're there, guess what? It's just test forever. Like, actually, day after tomorrow, I have a class. It's more tests. I have to do a class for my domestic recurrent, where they go through all the basics again. Not everything, but like they go through little things that they think we should focus on for that season or the season coming up. I know, Bruce. I'm with you. But you know, we do it because we love it. Yeah, we have a training class that's coming up in a few weeks. In the day after tomorrow, and it's another test. And then next month, that's another test. One's a domestic recurrent, where they go through kind of stuff where you need to know on the U.S. front, and then the international one, they kind of give you stuff on what you need to know internationally. So it's a constant learning here in the dispatch world. I'm pretty sure all the instructors have told you that already. So yeah, it's fun stuff. All right, let's see what we can go through here on these study guide. You guys have your study guides up, or you guys can see the study guide questions, right? All right, cool. All right, if you guys want, you can pull it up and you can go through them, but if not, it's okay. And we'll just do this as a conversational piece, and if you hear something that you want to add on to it, or if you have a story based on the topic that we're talking about. If you forgot to talk about it earlier, we can hear it. I'd love to hear your stories, or if you even have something random that you want to talk about aviation wise. We'll love to hear the story. Okay, so let's start with all right, so we remember the 4 types of frontal systems. If anybody can help me out here so we can have a open discussion about it. If you only remember 1, you only remember 2, let me know and we can go through it.
Cold front, warm front, stationary, and occluded.
Perfect. Perfect. Great. Great. At least I know that after I end this class, I taught you guys one thing. You guys are going to get one thing on the answer right. I like it. Oh. Let's see. And what kind of, well, we talked about what kind of weather comes with that warm front. And talked about it with the cold front. Do you guys want to go over it again? You know, we had talked about it before we left, but if you want, we can go over it again. Yeah? Or not? Thumbs up if we want to go over it. Okay, got 2. Okay, majority rules. We'll go over it. All right, so that that warm front, the weather that comes with that warm front, that steady kind of weather. So it could be slow, so you'll get that slow cloudy. It could be cloudy, it could be rainy, but it's that slow moving kind of weather because it's taking over that cold front. So you'll gradually see that buildup of that clouds and things like that, and it'll just gradually build, and then it'll improve because that once that warm front moves over, it'll then become the weather will improve after that. But in the beginning, once that front is coming, it'll be that steady cloudy or that steady raining, and it'll just move all the way out. It won't be like steady as in stay in one place. It'll just steady as in steadily raining and moving along, or gradually steady cloudy but moving along kind of thing, if that makes sense. It'll, because that warm front with that cold front will come together and it'll just steadily keep moving and go away, versus that stationary front where, like I said, they're both stubborn, so they're going to stay there. They're both going to that whatever weather that creates those 2 cold front or warm front, once they stay there, once they get together and they both decide they're going to be stubborn together, whatever weather that's there together. So if it's a consistent rain, it'll just stay there for a couple hours or something like that. It'll just stay there, versus that warm front will steadily move and gradually go away. And so with the occluded front, it's going to be like a mixture of rain, weather conditions, because it's that mixture of that cold meeting that warm and then coming back with that cold. So with the occluded front, it's that it brings in that trying to figure out the best way to answer this. It's that mixture of weather. So it'll be a mixture of like rain with precipitation and wind, but it'll be kind of a mixture of things. And then it'll come, and once that weather comes, it'll abruptly stop. It's not going to be as abrupt, but it's not going to be as abrupt with the occluded. It's just going to gradually go away with that occluded front when that front moves out. Which front is the one that moves faster? I know Christopher had asked this earlier. I think it was at the beginning of our thing. Christopher has asked, but does anybody know? Yes. Yes.
Cold.
Yes. Yay. Good. Cold front is the one that moves the fastest. That's the front that moves the fastest out of all of them. What are the 3 changes that occur when a weather front passes? So, remember when we were talking about thunderstorms, and I was saying that what creates a thunderstorm, pretty much? Like, what are the key mechanisms for causing for thunderstorms to happen? So with the thunderstorm, right, we need wind, and we need a lifting mechanism. That wind, that lifting mechanism, and we need moisture in the air, because that moisture in the air is gonna, depending on that temperature of that moisture, it's gonna move in different ways, right? And that instability, it's gonna tell us if it's unstable, because this, if it's steady, it's not gonna really create much, but if it's an unsteady, if it becomes unsteady, those are the things that creates a thunderstorm, right? So that's pretty much what happens when the 3 stages of that occurs for weather phases. The temperature changes, the winds, we have winds, and then the pressure of the air changes. All right, so those are the things that occurs when we have that weather that passes through. Yeah, let's see. And I don't know if we had went over what kind of weather is associated with that high pressure system. Did we go over that? Okay, so the type of weather that goes with that high pressure system, that's that system that goes like here. It's think of it as like a warm blanket. It just kind of covers everything. It's not drastic or anything. It's pretty much good weather. It's clear. So that high pressure system brings in pretty much a more calmer weather. We don't really have to, nothing really happens with that high pressure system. The low pressure system now, because it's going in on itself, and that wind, it's one of the causes for that lifting mechanism. So that's going to cause that unstable weather. So it'll be cloudy, like pretty much weather, cloudy, stormy, unstable weather, kind of, if you could say. So those are the kind of things that'll come up with the low pressure system. And we spoke about how that pressure system works. I mean, how it moves, that high pressure system moves, and how does it rotate? We spoke about that, right? High, low, high, low. Yay. All right, does anybody remember what the stages of our thunderstorms are? Not what the ingredients of the thunderstorms are, but what the stages are. They remember. Yes. Yes, Rebecca, thank you. Oh, you're gonna say something, Peter?
I was gonna say the same thing,
Yay,
but Rebecca,
great, great. Another thing that you guys learned, you can say Jody gave you that answer. Jody taught me that. All right. All right. So cumulus, mature, and dissipated. So remember that clouds that those air bubbles will come up and they'll cause, depending on the moisture of that, it'll cause that cumulus clouds, those clouds stacking up on each other, and it'll just start building, keep building, and it'll reach a mature stage where it becomes so much saturated with moisture that it just cannot contain itself, and then it'll start raining. And once it starts pulling out all that water, that's the dissipating stage of that thunderstorm. So we have that cumulus stage where that cumulus clouds come up and starts getting big and big, and just so big, saturated with moisture, and then it pops. After it hits maturity, pops, and then dissipates. So cumulus, mature, and dissipating. All right, let's see. What kind of weather phenomenon is associated with thunderstorms? So can anybody remember what kind of weather we said comes with thunderstorms? Like what kind of things do we see when we get thunderstorms? We were talking about that dry line coming in. If we have a dry line and a cold front and a warm front coming in, we'll get a bunch of different kind of weathers. Do you guys know what kind? You guys can remember off the top of your heads? Yep, that's right. Rain, hail, tornadoes, lightning. Yep, all that fun stuff. That updraft that we were talking about that I was saying, and then downdraft of that rain coming down really hard. That updraft of that wind coming in, and that downdraft of it coming down. So that wind taking it all over the place. Those are all weather phenomenons that comes with that thunderstorms, because when all that moisture comes in to play with the winds, that temperature of the air bubbles with the temperature outside, we can't predict exactly what is going to come out of that thunderstorm all the time, right? We just know that it's bad and we can't go through it. We know that it might be catastrophic with that category 5, or it could be just category 1 where it's not that bad. It's just a little bit of a thunderstorm, but not too much. What type of clouds is associated with thunderstorms? Yay. Yep, been saying it all day, all night. Cumulonimbus clouds. That's the sound, that's the clouds that associates with thunderstorms. And why are thunderstorms so dangerous? Anybody? Why is thunderstorms so dangerous? Oh, sorry, Christopher, what did you say?
I have like convective wind shear, like microbursts, things like that.
Yeah, that's right. When it comes to, yep, you're right on the money. It has all those different microbursts and stuff like that in them, so it becomes very dangerous. Now, when we think about flying the aircraft, so we're all thinking about Christopher flying his aircraft, right? When we're thinking about him flying it, what kind of danger do we think about when he's flying?
Other than the pilot.
Yeah, turbulence. Right. Right. Turbulence, that is true. That is definitely a danger that we have. Hail. Yep. Very true. Perfect. Yes, exactly. Rapid loss of altitude. Yes. See, this is great. It's great. All great answers. Rapid loss of altitude and damage to the aircraft. turbulence. We went over so many turbulence stuff with our light turbulence, moderate, and severe and extreme. We went through all those specific different kind of turbulence, right? But then there's also hail, because of all that different weather and different temperatures going in. Those rain can be frozen because of the temperature inside those storm clouds. So we don't know what we might get hail. You know, those lightning can be really bad, even though the aircraft doesn't really get that affect too much of the lightning. But if it's a really bad lightning, we don't want to go next to that, right? And rapid loss of altitude, because we spoke about the whole basics of how that air works, right? It cooled with that air pockets lifting and all that fun stuff. And we don't know what the temperature, based on the temperature of that outside air with the air pocket, it rising, it can either speed up the air, or it'll be a steady air, stabilized air, depending on how the air pockets lift and all that. All those things combined together, it can be really bad windy or not really bad windy. But if we get with that thunderstorm coming in, you know it's going to be bad. So that rapid loss of altitude is definitely one that we would look for with that wind shear, you know, all that stuff, and definitely damage of aircraft. That hail, nobody wants their aircraft to be hit with hail. That you could put a hole in that aircraft. I think there's a couple of aircrafts out there that have had real bad weather with the hail. Has anyone ever seen that aircraft with a hole in it caused by hail or even any kind of weather? What's the most damage you guys have seen on an aircraft? No one's seen any damage on the aircraft? All right. I know we're down to the... All right, Lakeisha, let's hear it.
I seen pictures of the windshield that got cracked, but it wasn't from weather. Well, maybe from that weather balloon that hit the United aircraft. I seen pictures of that, but nothing in person.
Okay. Yeah. I've never really the only damage I've seen is like when with that bird strike, and I've seen a hole in the aircraft because of a bird before. But yeah, I've only seen pictures with that from weather, with that hail hitting and with that crack windshield, and you definitely don't want to crack windshield flying. It's very dangerous. But okay, cool. Let's see. What's the difference between air masses, thunderstorms, and frontal thunderstorms? All right, so pretty much the air mass thunderstorms are usually, they're formed on warm, humid days because that surface is warmed up. That earth is the sun is warming up the sun, and the surface is heated, and that comes into play because it occurs during like the afternoon, because that surface, once that surface heats up and then the afternoon comes, it's trying to cool down. So usually forms warm, humid days for that air mass thunderstorms. And frontal thunderstorms, trying to figure out the best way to explain this. Okay, so it's basically what we were talking about before, right? Those frontal thunderstorms are because of those fronts coming in, overtaking another front, causing that abrupt weather, and causing those weathers because that front is moving in and coming into another front. Like that cold front just bulldozes and just creates a bunch of weather because it's just bulldozing. And but yeah, those fronts are definitely. Go ahead, Christopher.
Is it safe to say that the air mass thunderstorms are less dangerous, where the frontal can be much more dangerous and last a longer time?
Yes, 100%. Thanks. Thank you. Good way to explain it like that. Yep. That's exactly what that is. All right, let's see. All right, that dry line. We went through that dry line. Do you remember what that? Oh, Bruce, go ahead. Sorry.
I'm just gonna say the same thing as far as like the difference. Since the frontal storms form on the fronts, they're more stronger. They move more quickly and are more just dangerous. Air mass thunderstorms is they usually are more short lived and more stationary. I was gonna say the same thing as Chris. So.
Oh, okay. Beautiful. Thank you. It's a good way to explain it, so that if everybody else can't understand how I explain it, because I know sometimes I'm not very great at explaining certain things, but it's good. I'm glad that you said it in a different way. Thank you. All right, and so for that dry line, can anybody describe to me what that dry line is? What is a dry line? We went through it a little bit. Let's see if I can. Yeah, that's correct. Boundary between the dry air and the moist air. I'm trying to see if I can bring back up the picture that we had of standby. Oh. So yeah, exactly what that is, right? It's that boundary. Oh, it's that boundary right there between the dry air and the moist air. That's that dry line. I'm assuming you guys went through that the ceilings with Jaden. You guys know what the ceilings are? Did you guys go through that with Jaden? Yeah, okay, great. Perfect. All right. Do you remember the type of ice that we went through in the beginning? What type of ices are there?
Prime, clear, and mixed.
Perfect. Beautiful. Rhyme, clear, and mixed. And I'm not sure if it's on here, but perfect. Do you remember? I don't think it's on here, but I'm pretty sure you guys will get this in the future. What are the temperature when we're in icing conditions? Like, trying to see how we can put this.
10 degrees C and visible moisture.
Yes, that's right. That is correct. I don't see it on our review sheet here, or maybe it did, but didn't. But that's a good one to know because I feel like that one's always around. All right. Can someone describe that clear ice? Clear ice. No one wants to talk. Everybody's over this now. All right, go ahead.
It's glossy and clear, like the name, but it's the most common in the warmer temps. And then I remember you saying that it happens during flight, usually. But
Yeah.
it freezes over the wing as it's like pushing through the air.
Right, exactly. Yeah, that's exactly how it is. And yeah, that's what Jaden was also explaining, that because that water glides on it, and because it's flying, it just kind of glides on it and it becomes clear air. Yep, this is exactly what it is. It's in the name. Rime ice. All right. Brett, go ahead.
So rime ice is opaque because it's little beads of ice that are already frozen and stick to the airplane.
Right. Yep. That is correct. What is our mixed ice? Go ahead, Riley.
It's a mixture of the clear ice and the rime ice.
That's it. That's it. Doesn't get any simpler than that. And how does a pilot detect that they may be flying into a microburst? So I think I don't think I went through this one in detail. We went through that wind shear, but that microburst, I don't think we explained it in detail. But does anybody might have a clue as to what, based on what we talked about before? Go ahead, Christopher.
You can see a sudden increase in your airspeed, followed by a decrease in your airspeed, which, of course, those are typically low level because it's that downdraft that then goes. You're on approach, it's extremely dangerous.
Right. Yep, that's exactly what it is. Yeah, we went through a lot of that wind shear, but we didn't really describe that microburst, which is pretty much, that's essential what it is. That's that quick headwind and then followed by a strong tailwind, because that microburst is coming on you, just going through it pretty much. So it's increase in headwind and then goes by and then after that it's a strong tailwind. I think that's pretty much all the questions that we had today that we went over. Let us take another 5 minutes and then we'll come back and wrap it up, if that's okay. And then you guys can go through any, you guys can come back with any last minute questions before, before we finish up things, if that's okay. All right, sounds good. Does anyone have any like questions about what we went over? Anything that you want us to go over again or anything like that? No? Okay, we're all good. All right, that sounds good. Okay, all right, so everybody is good on what we went through today. So, okay, good. All right, let's wrap it up with any random questions, or if you want to, we could talk about. Go ahead.
No, I do have a random question. I was gonna ask. I wasn't here for like the beginning. I don't know if you already said it, but what airline do you work for?
Delta.
Oh, okay, cool. How long you been there?
Oh, yeah, I didn't say that. So I've worked with Delta Airlines for, in August, it's going to be 19 years.
Oh,
So,
wow.
yeah.
Did you start with getting an
Thanks.
idea here? I mean, like getting a license here, and then
So I started as a gate agent in JFK. I was in college, and I was one of those people that was like, "You're not going to catch me at this airline for long. This is only a small gig. Don't worry, I won't be here for long. Don't look at me." And that was in 2007. And then during probably around, I forgot what year, but like the economy just crashed. And after a while, I was like, well, I guess I'll be here for a little while longer. And so I was in college still while I was there. So I was on a don't care mentality type of thing. But then after I graduated and realized the economy sucks, I was like, you know what? We'll just hang out for a bit. And I actually liked what I did after I got over the immature stage of being a kid. I feel like being in college, you're still a kid. Your mind doesn't develop very well. You don't make good decisions until after. But yeah. So after that, I became a trainer in JFK, and then transferred to LaGuardia as a tower agent. So I was one of those people that once you land, the tower, ATC tower, will then direct the aircraft to the Delta ramp, and then I will take over and then direct that captain from the Delta ramp to the gate. That was one of the jobs that I had to do. And then also, we also had to coordinate everything with when the dispatcher plans that flight. I had to make sure that everything that the dispatcher wanted on that flight. So the amount of fuel, all those things are things that I had to make sure that was done for that specific flight. So like if that fuel density, because one of the things that I learned in LaGuardia doing that job was like that's how I learned about the density of the air and how that density of that air can affect so many things, like the fuel on the aircraft. It can either be too much fuel based on that fuel density or not enough fuel based on that fuel density. And so like one of those things, those are some of the things that I had to learn in LaGuardia, where they're like, oh, the fuel density, based on the fuel density at this time in the summer, we need to not put that amount of fuel, or you can't overfuel it because the fuel will change, because in the summer our temperature changes so much in LaGuardia. So things like that. I would work with the dispatcher a lot. And so working with the dispatcher a lot, the dispatcher in Atlanta would be like, oh, you should come and visit. And I'm like, no, it's okay. It's okay. And then after a few years, I was like, all right, fine, I'll come and I'll visit. And I came and I visited, and I was like, I love this dispatching thing. This is so awesome. My ADH brain liked the busyness of it. it's a lot of information. But liked it. And then afterwards, that's when, so this was before COVID, but then COVID happened. So after COVID, I decided to try and find a school. There was no school anywhere in LaGuardia. Mind you, we have an aviation school right next door to the airport, but nobody was giving the dispatching course. So I decided to go online and see what kind of school is out there. And then I found this Aircraft Dispatch Academy. And I was like, what is this? I called and they were like, because I'm not, you guys are awesome because I'm horrible at learning online. Like, I can't wrap my brain around it. Like, but I didn't know it was going to be this interactive. That's one of the cool things I love about this school. It's so interactive, and you guys can get on the phone and call anyone, and they'd be able to answer your questions without hesitation. All that fun stuff, you know. You have, even with the ADX, even though you guys have to figure out majority. If you have a question, they'll be able to answer it for you. You know, that's one of the things that I liked about it. And I decided to just do it because I was like, there's not a lot of options, and this one just kind of fell in, and it just stuck, and it worked out because I didn't even know that I had all these perks of sitting in the, because so after you finish your classes and you have a question, even now, me being a Delta employee, sometimes I randomly come in and sit in the class and listen to some of the instructors because you don't want to become complacent. You know, you want to be able to in order for you to be a good dispatcher, you always got to be learning, right? So that's one of the things that I really like about this dispatching school. You know, always come back and sit in or anything like that. So yeah, ended up here. And then after I got my dispatching license, when Jaden got hired with Delta, I was in his class. So I didn't know him, but then he told me when I saw him in person that he got the Delta job. I was like, oh, that's cool. And so that's how we all that's how I know him. He started when I got my license. That's 2021. And then I got hired with dispatching 2022, I believe, or 2023. 2020, I want to say 2023. Yeah. And I've been at Delta since.
Awesome. I'm guessing you love it at this point, right?
Oh yeah, for sure. Sure. It's definitely no hate, all love.
Gotcha. What do you think about the Allison just told me, I'm not sure if you know about it. Delta just started what is it, like a dispatcher program, like internal program, something like that?
Oh yes, they did start an internal program. It's always been there actually, but when I was getting into the whole dispatching thing, they didn't have it as often as they do now. They would take random, like you apply for it as an internal, and you would just have to, if you get it, you will still have to work your job and go to the dispatching class. So it would be kind of like this, right? You're living your own life, you have your work, everything like that, and you would still have to go to class on your own and do everything separately. So that's why I didn't do it that time, because I was in LaGuardia. They didn't take people outside of the state, outside of Atlanta. Yeah, so, but now it's different. You get hired for the flight superintendent assistant. So you'll get hired to basically learn to do dispatching, and guaranteed that you'll have the job after you're done everything. Now, you still have to pass everything, right? Like, you still have to be able to do the job. So if you don't pass the tests, you'll pretty much get washed out and go back. If the department still has an opening, you'll have to go back to that department if the opening is still there. But majority of people pass and get through it. So it's not too bad because nobody wants to fail, right? Nobody wants you guys to fail. Everybody wants to kind of see you thrive. So yeah, it's not a bad program though.
All right, thank you.
Yeah. Does anybody work for an airline right now? Oh, cool. What airline do you work for? Oh, Eric, a lot of people work for the airlines. Okay, cool. All right. Oh, I was all looking at the names. Okay, I kind of missed it. Riley. Let's start with, I think that's the name that I saw first. What airline do you work for?
I work for SkyWest.
Oh, okay. Cool. So that's gonna be easy for you, the face-to-face part.
Hopefully.
What do you do at SkyWest? Oh, Lakeisha works at United.
I've worked with SkyWest for 3 years. I've done a bunch of different things. Currently, I'm in the cruise support department. Before that, I was in the pilot training department. Before that, I was in the IT department. So I'm kind of just department hopping at this point.
Oh, that's good. You have experience, so that's good. You'll be able, you understand the backside of all that stuff very well. That's good. And Lakeisha and Mohammed works at United. Do you guys know each other?
No, I was just gonna ask him where does he work?
That's hilarious.
I work at IID. What about you?
I'm in the NOC in Arlington Heights.
Okay.
I'm an in-flight.
Because that's what dispatching is hiring.
Yes, sir.
Yeah.
That's how I got exposed to it.
Oh, how did you get exposed to it, Lakeisha?
Just being in the NOC. Got stationed right in front of one of the dispatch managers, and I don't know, kind of got bit by the bug. So here I am.
Oh, okay. And you said you're an in-flight?
Yes, ma'am.
Oh, okay. Which is funny because, well, not funny that you do in-flight. No, that's not what I'm saying. But a lot of
It's comical.
a lot of in-flight people that I meet, like when I'm flying, like when I'm doing my jump seat, they'll be like, I'll be like, oh yeah, I'm doing the cockpit jump seat. They'll be like, oh, what do you do? I'm like, I'm a dispatcher, and they're like, oh, what is that? You know.
Yeah, I had absolutely no idea what it was before I went to the NOC.
And there was one time this agent was like, we were trying to hurry up they were trying to close the flight, and the flight attendant's like talking me to death, like, oh, so you fly the plane? And I'm like, lady, we need to close the door. Yeah, sure. Because I'm like, she don't even know what I do. So I was just like, let's just go. But yeah, okay. Yeah, a lot of your peers probably don't even know what you're going for when you tell them, yeah, I'm doing this dispatching course. They're probably like, what? And Mohammed, are you like at the station, or what exactly is your title?
Yeah, I'm at the station. I'm a ramp lead, and I got exposed to dispatching from de-icing because I got certified, and then I started doing it for them. So then I was like, I can do this full time, right? So, and I kind of got exposed to it when they had this job thing, like inside the station, right? And then one of the in-flight people was talking to me. They were like, yeah, dispatching over in Washington, like they really need people, and getting certified isn't like really that crazy. You should look into it. Kind of let it just pass by until a position opened up. And I was like, you know what? Might as well I'll just sign up for the class, and then I'll go for it whenever they
Like open it again.
around. Yeah.
Okay, good. Yeah, hope you get it. I don't know how they are with internals. Like, if do they have like a good mix of internals and externals?
Yeah, they really try to go for internal. Yeah.
Okay, good. That's good. That's good. I heard a lot of interesting things about United, but I'm gonna keep that to myself. You know, in a good way, some bad, but you know, everybody.
Just Miss Jody,
And
just so
we'll
you
back.
know, my goal is to go to Delta. So you don't have to stay much there.
Yeah, I'm not exactly too in love with United.
Okay. Well, you can all come in Delta. You guys seem like you guys all know your stuff. And if you guys can listen to me for 4 hours, I'm pretty sure you guys are in the up and up. Like you guys definitely in the up with that one. But that's cool. That's pretty good. United, 2 Uniteds, and you guys didn't even know each other. So Mohammed, are you in Chicago?
I'm in DC. I'm in IID.
Oh, you're in DC. Okay, okay. Oh, IID, that's what you said. Yeah, Bruce said his fiance works is a flight attendant also at United, so he hears all the frustration. That's funny. Okay, cool, cool, cool. And who else said they work at the airlines? Caitlin, what airline do you work for? What do you do?
I work for
you think it's-
Spirit.
Oh yes, I was about to say you did tell me the airline.
Yes, Spirit out of MCO for the past year and a half. Yeah.
Okay.
Yeah. I like it. It's the operations department, so we're right underneath all the gates. I like it.
Okay.
It's just I like to be busy, and it's either really slow or it's so busy that you're losing your mind. And I've been kind of wanting to do dispatch since I graduated college, so now it's like the perfect time.
Okay, great, great. Oh, that's cool. Spirit in Orlando. That's good. Because that's their hub is in Fort Lauderdale, or is it Orlando as well?
Yeah, it's by Fort Lauderdale. I can't think of the exact name, but it's over by Fort Lauderdale.
Oh, okay. So that's good. Do you want to stay in Spirit?
I wouldn't mind it. I just don't know if they'll be hiring. Because I know we filed bankruptcy. It's been a while now, but they had furloughed a lot of dispatchers. So I don't know if I know we're raising our flight volumes back up, but I don't know if they'll be hiring more again. That's something I can look into. Yeah.
Yeah, a lot of Spirit employee dispatchers came to Delta. A lot of Spirit people came to Delta. So
good for them.
yeah. We have a few that actually worked as dispatchers in United and left United and came to Delta. So not to toot Delta's horn, but
Not to pride, but because my top airlines, like obviously like Dream Airlines to work for eventually would be Delta and United. What's wrong with United?
Nothing's wrong with United. Nothing's wrong with United.
Okay.
We're just better.
Friendly competition.
Yeah, right. No, nothing's wrong with United. Okay, cool. And Brian.
Just for the record, I live in Atlanta and I want to work for Delta too. So, yeah. No, I did have a question though, about when you got into like the international flights. Like, how long did you have to be dispatching before you could do that, and what kind of training and everything did that involve?
Oh, good question. It's more training. It's like a lot.
It's like ETOPS and stuff, right?
Yes, exactly. So with Delta, once I got hired in April, finished my domestic training in about October, November. Oh, Betty said she left United. So I started in April, finished my domestic training in like September, let's say the December, because I wasn't officially on the schedule till like about Thanksgiving time. And then I stayed on that. You have to do a domestic for at least a year. So you can't do international until you've completed at least a year on domestic. Well, majority of people, when you start, you basically get forced because a lot of the senior people tend to want to come out of the international because they don't want to do midnights and stuff like that. I actually just chose to go in there and do it because I'm like, it's gonna be a lifetime of training. Might as well just get it over with, you know. I'm on a roll of being in class. Let's just keep the train going, you know. So I did that right after. That was a year after. So I just started international maybe in 2004, like the ending of 2004. That's when I did my training class. Yeah. And then did 2005 international. So yeah, about a year. And the training is very intense because I just finished international. You know, for me, I was very terrified just doing domestic alone, because you think about it, you know, you're literally responsible for this metal that's flying. You and the captain have sole responsibility, and you know, you try to give the captain as much info as possible. You know, you try to be on the same page as the captain, and you do the best that you can to get that flight from point A to point B safely. But you just still get terrified because you're like, what if he calls me and tells me that one engine is on fire? You're like, holy smokes, you know. But surprisingly, half the captains are like, if one engine is on fire, it's fine. We can just drift down to a location. You know what I mean? We're in the United States, so there's always somewhere to go to, you know. Internationally, no. So like my flights from Korea to Seattle, it's literally water. That's all you're in. Water. There's no land to just drift down to, you know. So you know, that's one of the scary parts of it. So you have to like learn all these things as to what happens if this, you know, because a lot of the things with dispatching is one big thing happens, so you have to kind of, oh yeah. Nichelle said all she saw was water when she went to Thailand. Yep, that's pretty much all you're flying over, water. Yeah, so like you have to learn so much more details as to the country. So prime example, I do one of my main desks that I do is Pudong, which is China. They have a lot of rules. They have way too much rules. For example, you can't fly you have to fly at a certain altitude when you're leaving there. Your flight number can't change. Your route has to be approved. And they don't divert there. And if I'm going through a weather, they tell me what airport I'm going to. So I have to make sure I have enough fuel for them to tell me you're going there. You can't go there. You know what I mean? Doesn't matter what's on my flight plan. They tell me where to go. And I have to have enough fuel for it. Like, what? But yeah. But once you know it, though, it's not bad.
That's cool. You know, I have a funny story kind of related to flying to Asia. But I guess almost 30 years ago, I flew to China, and I flew from LAX to Beijing, and it was on China Eastern Airlines. And we actually had to make an unscheduled stop because we were running out of fuel. And literally, I think they just picked the first airfield once they got over the border in China. We had to stop in Harbin, which is like way in the northeast corner of China. And we just land on this abandoned, it seemed like an abandoned airfield. There was nothing going on except for a bunch of soldiers just standing at one end of the runway. It was so weird. And we had to refuel. I guess we had just hit too many headwinds or something going over there. But I was like, is that something you have to deal with? Do you have planes running out of fuel headed over there? Or I would think they would plan for that.
Right. I mean, as a dispatcher, that's one of your sole purpose jobs is to plan for.
Maybe dispatching 30 years ago wasn't as good for China Eastern. I don't know.
I don't know. Each airline has their own rules, so maybe they have a different version of how their fuel is. But Delta has like a strict, like, especially internationally, they're like, no, we like overcompensate a lot with fuel when
Yeah.
it comes to international wise. Oh wow, that's crazy. It
Yeah,
was
it's wild.
I had to divert one of my China flights, but not for fuel, for a medical. The passenger was almost dying. They had a really bad medical situation, and we had to stop in Japan. But you know, one of the things, like, this is one of the unique things that I like about dispatching. You learn so much different things politically also, because I mean, I knew Japan and China didn't get along, but they just don't get along. Like, so we were flying, and because our Russian airspace, we don't fly over Russia anymore. So we had to literally declare the emergency after we passed Russian airspace, so that they don't, because if we're declaring an emergency, it doesn't matter. You have to get in, right? But we had to wait until we leave Russian airspace. And then once we pass Russia, we had to stop in Japan. Now we stopped in a place called Shitoshi, where it's kind of like that. It's just a strip of land, but it was actually a little bit of people there. We had luckily one of our maintenance there. Don't ask me why our Delta maintenance was there, but he was there. But literally, the rule was, because we're going to China, we literally had to land a plane, take that one passenger off, close it, and get back out. There was no mixing, no. You literally land, took that one passenger off, lock it, and go. Yeah, so you have to go through like intense like things like that, because they want to play a political game, right?
Yeah.
Crazy. But yeah, I like it. Anybody else have a crazy or story that they want to share? No? All right, we're about to wrap up anyway, so that's cool. Well, it's really, really nice meeting all of you guys. Not sure if I'll be back on here. But if not, I wish you guys a very, very, oh, thank you, Chris. I wish you guys a very, very, very good endeavor on your career. I hope all you guys get what you want and get to where you guys want to be. And if you, thank you guys. If you guys have any questions, actually, I can put my number here. Like I said, I won't be on here, but yeah, go ahead. That's fine. You guys can put me down as reference if you want to. No problem with that. Oh, all right. So I'll put my name here. Oh, sorry, my number on here. If you guys have any random questions, and I'm up at midnight, so my time is very different from the East Coast. So I'm up at midnight. So if you guys want to send me a text or something, everybody else is sleeping. I can always try to help you guys. So what were you gonna say, Peter? Sorry.
Oh, yeah, unrelated question, but I'm just a little bit curious. What's a first or second year dispatcher expect to be earning, taking home?
As a Delta dispatcher?
Sure, Delta or any other airline you know about?
I'm not really familiar with other airlines, sorry. But with Delta, you start at, and this is, I guess it would depend on when you guys would start, but you would start at about 90, between 90 to 100. That's your starting. And for Delta, you get a raise up to 10 years. And right now they end and like I said, this all is relevant to, okay, and same as United. That's what Mohammed said. So Mohammed said the same as United. And this all depends on what union contract it is or whatever at the time that you guys get hired or anything like that. But they would they would tap out at about 225, between 2 and 225. Okay, and Bruce said American is around the same as well. Do you know someone in American Airlines, Bruce?
No, but I have that spreadsheet with all the pays for each airline, regional, majors, all that, and it says like all the
Oh, okay.
structure payout and like the end of year payout.
Oh, okay. Yeah, yeah.
But it says send that to them. Let me know.
Oh, okay, cool. Ray Rayleigh says it's not the same at SkyWest. I agree. That is why I did not go there. I was at Delta already when I did my certification. I was like, when Jaden was telling me what they make, I was like, what? And I don't even remember. I think it was right before their contract up though, so they don't make that less of what they were making back then. But I was like, I can't leave my Delta job to go make that. But yeah, it's not good. But you know, if you're in that area and you want to just get that experience, I would say do it for that experience, especially if you're not if you haven't started at an airline yet, if you're not like at a major and you get accepted with SkyWest, I would say start it. Just do it for the experience. But if you're already at a major, I wouldn't say leave the major to go to SkyWest, only because you're already at a major. SkyWest is great. It's great for the experience. Go ahead.
I was gonna ask something kind of around that line. As an external hire, is it hard to get into the majors right away? I would assume so.
Yeah, based on what I've heard everybody talk about, it is not that easy to get in as an external, but a lot of people get in. You just have to apply. You know, I don't think that it's like impossible. I don't think that you wouldn't be able to get it. You just have to apply. Like, you know, there's one person that's applied to all of them, all the airlines, and only got accepted to like one and just started there, which was like, I think, Endeavor. And then they ended up coming to Delta. And then you have, I've heard another person who got accepted to all of them and had to decline half of them, and then they chose Delta. So
that sounds like a good problem to have.
Right? Right?
Nice.
Oh my gosh, what? Me as an internal, I applied. This was my second time applying. My first time I didn't get it. I was like, oh my gosh, you're lucky. But yeah. All right, anything else before we wrap up? No? I know. It's time for you guys to go to bed. It's been lovely. And thank you also, Brian. Have a lovely night. Thank you all. Have a lovely night and take care of yourselves. Again, if you guys have any questions, don't hesitate to give me a text, even though you guys probably might not see me in the class, or who knows, you might, not sure. All right, have a good one, y'all.